right, looks good. Okay. Good morning, nobody. How's it going? So today it's Monday morning in Australia. It's getting a little bit colder, but we've got to continue on this thing because if you've been working on something like this that's so boring for so long, you really should finish it, I think. So today we're going to continue working on, if I get the iPad up, here we go, this SCTE 35. So I've written a bit of background info here. Basically, anybody who is new to this project, I'll just do a quick overview. This is a binary message protocol that's used to signal ad breaks and other kind of timing info to video players, to encoders, sort of video equipment. It's used probably the most places people will see it is in HTTP live streaming or HLS, and that's how you'll watch things on Twitch or with like a on-demand like streaming platform like Disney Plus or whatever else is out there. Basically what happens is that your browser or your video player will download a plain text file that looks something like this. So lines beginning with a hash are they're called tags, and these contain like metadata about the video files that are coming up. So anything not beginning with a hash is just a video file that's downloaded, rendered, and then you see it on the glass with your eyes. So here's a 2-second file, another one, and then we hit, I don't think this is the right tag, but it doesn't matter. The point is that at some point you're going to hit something that contains a base 64 encoded SCTE 35 message. So what we want to be able to do is have our package, our SCTE 35 or SCTE 35, I don't know how you're meant to pronounce it. But anyway, we want our package to be able to encode and decode these ones here. So roughly it looks something, at least in our package, it looks something like, one of the main types we want to look at is this Splice info here. So it contains just a bunch of fields, things like timing, when, how long, any sort of encryption information, stuff like that. To be honest, I'm barely familiar with what all of these fields actually mean or do. But that's okay because the specification is a lovely 120-ish page PDF that includes a lot of, tells you what the fields should look like, whether they're a number or whatever other types of data types. So here's our lovely 123 pages, there we go. All right, so today what we want to do, I've actually written out a couple of bits and pieces, but the main theme of today I want to do is basically just to try and decode and encode more of these messages that we can get, and specifically more of the commands and the sort of like the parameters to the commands, or these Splice, these descriptors. We're doing a couple of them so far, but there's a few more that we want to test. So one of the things I want to do very first is test encoding of Splice info. And then what we want to do is also test test more of the samples that we get in the specification. So these are known, good, valid, encoded and decoded SCTE35 messages that are given to us in this big spec document right at the end. So test more of the samples from the spec. So right now we're doing two, but maybe we want to do, maybe at the end of today, you know, maybe we want to get to, I don't know, maybe 4 or 5. Oh, let's say 5. Optimistic. And there's just a few other little bits of, let's see, I've written a few things down. Oh yeah, so one of the other things that we probably want to do is, there's a few bits where we can maybe do a little bit more idiomatic bit packing and binary encoding stuff. So what we can do is we can copy how the standard library does things for a few sort of important fields that we're going to be encoding. So we're just going to do I'll just put an example here to remind myself. Oh yeah, so put PTS and appending bytes to buffers. So we'll just do append seeing any other bits and pieces packed here. Code splice info. I think that's pretty much it. I'll just check. There's also another thing. We're going to use the built-in copy function. Just want to check that we're using that in all the places that we can, because that's actually going to save us a lot of code. I've noticed that the first sort of couple of days we've been working on this thing, I was kind of just hacking stuff together, as you do, super important. But I've learned that there's a few handy little built-in functions in the standard library that can save us from needing to like juggle a whole bunch of slices and arrays and buffers in. So yeah, if it's there, why not use it? Okay, so let's just get going. So it's pretty easy to start, because right now if I just make sure we can see this, it should be over here. Great. So we can see that we actually have a failing test. And what we're doing here is we're encoding this splice info and this splice insert, and both of them are failing, so we're not getting the result that we expect. Here's the byte representation of it. So what we can sort of see if you kind of squint is that we have, let's just say for this example here, we're expecting F0x FC3034, and we're almost getting there, FC30 and then blank. Then a whole bunch of other stuff there. We're actually looking quite good at the end there. If you see, we've got FF000. But we want to check that we're encoding it all correctly there. So what that'll look like is how the actual values that we want to look at are going to be in here. So when we encode, we're going through field by field and setting the correct bytes and bit fields that we need to then actually, send it on the wire to some kind of server over the network or whatever. Yeah, so I think we should just jump right in and have a look at this test. So what we're doing here is I'm going to test case. All right, so we've got one test case here. Again, these are from the samples right at the end. So if we have a look, 14, here we go, yep. So they give us, oh yeah, they give us, what do we got here? 8 examples. So that's cool. Let's, so right now we're working on this test. We can just look at it here. Yeah, we'll leave that there for now. Okay. So, oh no, I forgot the function. Encode splice info. Okay, so that's in here. All right. Let's see. So looks like, see, that's byte 1. Oh, so we'll go by index. So that's 0, 1, 2, 1, 2. So it looks like we're not setting the byte at index 2. And if I remember correctly, we're never actually calculating the length. So if I go all the way down, what we want to see is the length of this, of our buffer, because what's actually happening in the binary encoding, we have, find the bit that we want. Yeah, here we go. So this is what it looks like binary encoded. So we've got 8 bits to start with. And then we're setting a couple of flags. We're setting our SAP type, whatever that is, there. And then we want to set our length of all the bytes coming up. But we haven't set that yet. So we'll do that at the end, I think. I know I've written that, but we really need to do that at the end, actually. Not just a comment, let's actually write code that does it. Okay. Actually, let's write the code that sets the length now. See how we go. So this is a 12-bit integer that we need to set. So this is where I like drawing things, because I'm get pretty confused by all these unusual number sizes. Normally we've got 8-bit, 16-bit, 32-bit numbers, but now we've got 12 bits. So let's see what this should look like. So we're going to have, as I said, we're going to have a buffer, and then we've got an index 1 and index 2. And if I look at the spec, what we've got here are 1, 2, 3, 4. Okay, so I'm going to split this up into bits. So I'll get here 1, 2, 3, 4. So this is the subtype, and these are, okay, so this is just some flags. So we'll just call these flags for now, because it's not important what they are. And then let's do, and here we're going to have 1, 2, 3, 4 bits, and then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So all of that is going to be our length. So we're going to have 8 bits and 4 bits, like that. It's 12 bits. So the length is going to be bufflen is a uint 16 at first, length of buff. And we're gonna need to so that uint 16 is 2 bytes so far. So we've got bufflen is 2 bytes, but it's 16 bits. But we want 12 bits. And specifically, we want to knock off the first, so like this, we want to knock off these 4 bits. So we want to mask that. So the mask that we are going to need is 0, 0, 0, 0, 1, 2, 3, 4, and then we want to keep all these ones as well. 1, 2, 3, 4, 5, 6, 7, 8. That's in binary. So in hex, that is 0x 0 f f f. So our mask is Ox F F F. So let's get that. Just say 12-bit length. And then we can start to actually set the values in the buffer. So again, we're going to be going from, we're going to do index 1 and index 2 there. So let's set it. So our first one is going to be 1, and we're going to toggle the, we're going to use the first, let me get this right. Yeah, and then shifted. Yep. So what this means is that we're getting this length. We want 4 bits. So we turn the first thing into, we turn it into a byte, but that'll give us 8 bits if we just turn it straight into a byte. So what we really want is, yeah, shifted right to 8, yeah. Cool. And then, of just the length. Okay, so let's test it. We have here, we want the value 30, we want 3034. Let's see what we get. No, 3015. Okay, well look, at least we know that we're setting the right bits, so that's cool. What we want to do, I don't think, well, I'm not super confident that the length is actually correct, because we haven't gone through and checked all the other stuff that we're doing up here. So let's go through that. But that's cool, that's good. I actually was expecting something really bad to happen there, but all good. tempted to actually make a commit just like that, because that's, yeah. Anyway. Oh, and let's put a comment here. So the left 4 bits are used by flags and sat type. Just so it's clear why we're doing this. Or rather, because here we're just appending, but what we want to do is left 4 bits. Let's do this. Then all we're doing is we're setting the value of those bytes. Still good? Yep. Awesome. All right, so I might actually chuck this up here. Next up, let's go through and just double check. So this splice is not encrypted because it's not set. So next up would be the presentation timestamp. That's the PTS, and that's also not set. So we can go down the tier. So the tier that we want is 0FFF. And that I don't see here. Sorry, we don't get that in our result after we encode our splice. So let's see, let's review this tier code here, pack tier. So here this doesn't really seem necessary to have a function here because yeah, we can, anyway, let's just have a look. The tier is a 12-bit integer again. So the CW index is easy, just a single, oh, we can actually do this because it's a uint8, so I'm pretty sure that should just let us do that. Yeah, great. So a uint8 is a byte in Go, so we don't need to convert it to a byte and then append that. We can, yep, easy. Less words, same result. That's what we want. Okay, so we're gonna look at this packed here. So the tier, what I might do here, because I can see that these things are 12 bits and 12 bits, so we're going to have a similar thing to what we had before. We're going to have 2 bytes, sorry, 8, 16, 24, 3 bytes now. So how this is going to look is we're going to have like 8, 4, sorry, let me get this right. So we're going to have 12 bits. Let me just set this, so it's going to be index. No, we don't know the index, okay. 8, 4. So that's going to be our tier. And then this bit is going to be our command length, cmd_len. So to pack our tier in, which we store in Go as a uint16, what we want is to our packed tier is actually going to be our tier, but then masking off the last 4 bits. So it's going to be tier like minus 4 bits, say. So really what that's going to look like is tier, and then again our hex is going to be like that, because that's masks the last 4 bits. So if I remember rightly, yep, so this is wrong. And we can actually do this all in one line, I think is relatively clear. So what we're going to do is we're going to first, our tier is really, so that's what our tier is going to be on the wire, and then we can then just append that value to our buffer. Now we can use the append uint16 in the Go standard library for this, which is cool. So I'm just needing to do this stuff. Let's do that. So we'll go equals appending the tier, to buff, and the value we want to append is that. Now we could even, if we're really cheeky, we could do that. I'm not sure whether that's okay. So we'll split it up for now. It's because this is our first go at it. Okay, that's good. Just double check that's correct. Yeah, that should be right. So what we've done is we've appended this one and this, and then these are zeros. Right now they're zeros. So let's keep going. Oh, VDM3. Oh yeah. Thanks, VDM3. Hope this is interesting or useful or something. I don't know. If there's anything you want to see or anything, just let us know. We're just hacking away here, not really doing anything too serious. Appending uint16. Alright, so we can delete that function altogether. So we've just smushed it into 2 lines, and we could almost do it in one. Okay, we check if it's nil because it'd be nasty nil pointer dereference otherwise. Panic. Okay, command. The length is let's call this CMD len just because I have a few other lengths there. This is actually going to be the same as this. So let's so this time now we've got a uint16 with the length of the encoded command, since this gives us a byte slice back. And then we want to yeah, this doesn't seem right to me either. So what we want to do is because the length, again, we have to ensure that we're only getting let's see. Oh no, see, this is wrong. Sorry, okay, hold up. So the values we actually want here are this, since we only want 12 bits. Yeah, that's it. So just in case this is set to something greater than 12 bits for whatever reason. So we make sure of that, and then we append that to our buffer. No, I'm getting a bit lost here. Okay, no. So we're going to have 12 bits. And shift it along. So we know that this is correct now. Nah, okay. So what we need to do is we need to do a bit shift here as well. So we need to take our, so in this example, let's say our tier is going to be 2 bytes. So what we'll need to do is, and what we've done is we've knocked off these bits. We don't care about them. So then our tier that we care about is all of this in here. That's 12 bits. But when we put it into our buffer, we need to smush everything up because we want actually 4 bits here spare to put in the command length. So this value is actually going to be, or we can, like that. Oops. So the right 4 bits are for command length. So let's put that as a comment here. Yeah, or even here. All right, so now we move on. So we're going to go to here again. Now this time for the command, the command again is going to be 12 bits. Or the command length, rather. Ooh. So this time we're gonna, what the fuck are you actually doing? Somebody asks, what am I doing? So what this is a, we're encoding a data structure here, this one, and the data structure is from a binary messaging protocol that's used to signal breaks in video players and video equipment. So it's used in like online video streaming services. So it's a way to, to signal to those things saying, hey, like there's an ad break coming up for 30 seconds or something. So if you want to put in a clip, now's the time. And it was actually originally used for cable TV, but they still use it in like the modern IP world. So yeah, for that, that's a quick summary. If that makes sense. So this is used by the tier. There we go. Oh, wow, yeah. Hey there, all the way to the UK, wow. Cheers, mate. Yeah, hope it's helpful or fun or interesting or whatever, yeah. Thanks for joining us, because it's fun to do this, with a few other people, because, it's no fun on your own, right, doing this stuff. At least for me, I don't know, I need people to help me pick up on bugs and stuff like that. So again, we're going to get our command length, and we want to ensure that we're only getting 12 bits, like this. And now we need to put our length into the buffer. So this to me actually looks, this might actually be okay now. So what we're doing is we're getting the, into the last byte, and we've got, let's try that, oops. So we're putting in the length of the command and then the actual command, the encoded command. Oh, we don't need that anymore. confirm that that's correct. So in the spec, they actually tell us how, I think they give us these values. So if we go up to here, command length is just 0x5. So what we can do is we can actually just print this. Oh, great. Yep, looks like we're getting it. Right, it's 5. Oh, this is on my hex. I don't speak hex very well. Let's do that. Yeah, great. Okay. Check. OX5. Awesome. Okay, so yep. Okay, so we're encoding our command length. Okay. Let's get rid of that. And our command. Yep. All right. So next field that we're doing is we've done the command. Next up are the Splice descriptors. Okay, so the first thing I see straight away is that we're not actually appending. So we're writing all of this data into this buffer, but then we're never appending it to our, to the buffer that we're returning. So we'll need a like that. Let's check that how we encode the length as well. So if we go to our spec, this is the length of buff1. So we've done command. This will be this here. So it's just a plain old 16-bit integer, so that's cool. We can just use that. Length of buff1. Okay. It seems fine. So we're adding that, and then we encode that. And then double check that we're actually doing this correctly. Yeah, so we're left 4 bits are used by the flags and the sap type. So this is, did I do this up here? Yeah, so let's just double check this. Oh, we're getting something quite different. Yeah. E02. Okay, yeah, I see some. Okay. Let's double check. So Splice. Oh, great, look at this, we've got our length correct now. All right, so this bit here is yeah, so that's definitely okay, and we're actually getting the correct length. It's just our values are wrong. So part of the way there. We might want to check that function. I think we definitely want to check that function. I just want to see why the so encoding out here. BTS adjustment is 0. And all of that is 0 too. So that's 7 plus 33 is 40 bits. 40 bits is 5 bytes. So yeah, 1, 2, 3. Oh no, maybe more. Sorry, hold on. Protocol version as well. Yeah, okay. So 6 bytes. So we want 6 of 0 here. 1, 2, 3, 4, 5, 6. Okay, let's go again. 1, 2, 3, 4, 5, 6. One, two, 3, 4, 5, 6. Okay. And the CW index. The CW index thing should be 0. Right, so we're not even setting it. Oh yeah, because it's only for, yeah, that CW index is used. Represent on 1, 2, 5. What does FFFF after the zeros represent on 1, 2, 5? So those ones are the protocol version, which is a constant of 0. So if we go down here, maybe that's then we've got a byte that tells us about the encryption. So that's 1 and 6. And then we're setting the timestamp adjustment. And in our case here, the timestamp adjustment is 0. And that is 33 bits. So that's 5 bytes. Have we got yeah, so we're going 1 and then the rest of that, so that's 5 bytes there. And then we're adding CW index, which is, in our case, is 0. So what I'm expecting is what we're getting here, because we've got, first up, we've got the protocol version there. We've got the encryption information there, and then we've got also part of the timestamp. So let's go 1 and then 1, 2, 3, 4, 5. So that's 6 bytes of zeros. The problem is that when we're encoding, we're not getting 6 bytes of zeros, we're getting more. We're getting 1, 2, 3, 4, 5, 6, 7. We're getting 8 bytes. So maybe then, if we're getting, instead of 6, we're getting that, maybe the CW index is definitely 0. Yeah, I say that. Yep, so that's 0. It's going to be this tier again, isn't it? I think our problem is going to be at this. It's right here. Hi, that editor is the, this is the Acme editor. So I'll just, that's Acme from Plan 9. So I'll just, I always get this question. It's funny, people think the editor's really weird. I guess it looks different, yeah. This is a good, and then there's also this video by Russ Cox. Yep, this one. This is a really good walkthrough. Of the editor and how it works and why you'd use it, and it's different to probably most. All right, so let's get back to our things here. So the tier. Vim motions option. Yeah, that's a good idea. Although 6 and not 8 bytes. Well, here it should be 16. I mean, here we know that it's, so the length here is 6 and not 8. This should be because we've got a, we know that it's a uint 16. Oh, okay. No. No. Okay. I think I'm looking in the wrong place because we tested before. Yeah. See, we know that we get the correct command length. So yeah, somewhere in here where we're getting an extra byte. Is it the P? Is it maybe that? Okay, so this is actually one of the things that I wanted to look at was yeah, here we go, this one. This put PTS because how it works in the standard library is you have these functions, put uint 32, and then it actually puts that into the byte slice. So what I want to do is actually get this value, which we store as a uint 64, but really the only value that we want out of it is a 33-bit integer. So what I really want is actually a function that puts the 33 bits out of the timestamp into the slice of bytes that we give it. And then we don't have to worry about doing all of this stuff in this sort of hairy function. And we can test it independently and all that. So what I want to do is put PTS into a given byte slice, and then the PTS is, oh yes, this is going to be the PTS, by the way, the presentation timestamp is, that's the number of ticks of a 90 kilohertz clock. So it's just a way of representing duration that's used in kind of hardware. Anyway, so let's do this, uint 64. And we're going to have to let it panic if there's not enough bytes, just because that's all we can do. Okay, so first up, let's make let's turn our, I'm going to put this over here. Oh, yeah, no, I'll use this, put this here. So what we're doing is we're on an array of a slice of 8 bytes. Now our PTS isn't actually, we're going to get the, so let's do this here. So what we've got here are 8 bytes, but we only want 5. So we don't want 1, 2, 3, 4, 5. We don't want these because we only want 40 bits. Well, we only want 33, but to get, so here we've got, we go here, we've got 8, 16, 24, 32, 40, 48. 1, 2, 3, 4, 5, 6, 7. Oh, and then 8 at the end here. Whoops. Yeah. 56 and 64. The value that we really want is actually 33 bits. So we'll get it from that, there, and here. But we don't want this. We want 33 bits. So to get that, first we'll need to get a slice of from index 0 to 0, 1, 2, 3, 4. So that'll be actually 0 to 5. Just to 5. And then we're going to grab the, let me get this right. Just make sure I'm getting this. Oh, sorry, I got my messages on 64 to 32 bits of 0. Yeah. Yeah, that actually, yeah, that seems like a better idea, yeah. So I'll get shift left 64 to 33 bits of 0. So that'll be, yeah. So you mean like here we'll go this way. Yeah, we'll get this because that's 64 minus 33. Something like that. Oh, I just realized I've gotten this wrong. Yeah, okay. No, I've got this wrong. Oops. So it's going to look something like, one, two, three, 4, 5, 6, 7, 8. So from here we're going to have (33 bits). Hard to put it into words, but I think what I want to do is actually like that. Pretty sure. Sorry, got my messages on YouTube here. No, figuring. Oh, the one is done. I said it. Yes, that one. Okay. Learning golang, same like Google. Looking for good results in a special web dev site. Okay. Okay. So no, this editor does not have. Well, it has. It has an editing language that is. Oh, another person asking about the editor. Hi. So yeah, this is called. I actually have a bit of info on Twitch about it, so I'm gonna find that somehow. So the editor is here, and then, oops. No, of course that doesn't work. All right. Sorry, just trying to get this message posted across the two different. Oh, man. There we go. Yeah. All right. Yeah. So, what name? Yeah. So this is this editor does not have those sort of motions that you see in VI. The only way to move the cursor is, well, actually, yeah, look, okay, there's a few ways to move the cursor, unusual ways, but the most VI or sort of ED or ed thing about it is the command language you can use to edit text. So if you're familiar with like sed, for example, you have a similar thing in Acme. Resources to learn Go. Look, to be honest, I don't know any really good beginner ones, because I came at Go from a sort of sysadmin or sort of SRE place. So I was doing, I was already in IT and doing stuff for a few years before learning to program. But I think, you know, gopl.io. I think this is always a good book just because it's pretty short. So I'd recommend that. Look for could you make a UDP tunneling tutorial after video streaming? Yeah, sure. That sounds like a good idea. It could be interesting. I've got a couple more video streaming stuff to do that I think would be might be interesting. But after that, yeah, for sure, I'll have a go at it. I've never done UDP tunneling, but why not give it a go, right? This IDE is not running on the iPad. This is just running on my desktop. I'm running on my Mac now. Normally I use OpenBSD, but I use the Mac for streaming just because I plug the iPad in to the computer. So I just have it like literally just connected to a cable into the back of the iMac. And then I just write down as I go. Yeah. Okay, there's that. And then, all right, so let's see where we were. I want to get the presentation timestamp. So let's do a, do that. And then, no, you know what? So what I'm going to need is the max value for a 33-bit integer, and then we'll just like say minus 100 out of it. I'm not sure whether users and the program just asks and runs whatever as a programmer. Do you think they might use a system like that as a replacement for the shell? How about one of the things you can do is try and make it and see how it feels. If it feels good, then share it. If not, then yeah, maybe that. Yep. Okay, so that this is the value we've already got. So this is so max 33-bit int minus 100 here. All right, So finally, let's test encoding this. Well, let's make a buffer first. So I'm going to get here we're going to do a slice of 5 bytes because that's what we need for a 33-bit integer. And then let's put our timestamp into that buffer, and then finally let's just print the value of the buffer. Okay, so I can already tell that's wrong, because what I would expect to see, you know what, let's even print out the binary and really see what's going on. Yeah, okay, there we go. So what I'm expecting to see here is a lot more bytes being filled up. And specifically what I mean is we want to see approximately 33 bits full. So we should see something like that. All ones. But we didn't get that. So let's actually write that out. So if might be able to do an array. So we want the array of 5 bytes looking something like this. 0, and then the next, oh no, sorry, no. The first byte is going to look like 1, 2, 3, 4, 5, 6, 7, 8. Next one is going to be, and everything else is going to be all ones. So let's just do ff. 1, 2, 3, 4, 5. Okay, and let's just do this over. So 1. Okay, and then okay, there's our test. 1. So we go put PTS. Oops. God, my hands are so cold, I barely type. Okay. Okay, ticks. Oh yes, good point. Good point. It does not. Let's actually, yeah. Thank you, VDM3. See, this is, yeah. Let's just do that. So that's the maximum. Is that right? Or 0, 1, 2? Oh no, they're minus 1. Is it right? That's the maximum value for the unsigned. Okay, looks like we've definitely not got that right. So let's so we're going to get the timestamp. We're going to have 5. Zero, 1. So we're going to get the indexes here are so the index is 0, 1, 2, 3, 4, 5, 6, 7, 8. So the slice that we want is from 0 to here, so that's to 5. Seems okay to me. And then we want the no, okay, so I think it's the last, yeah. So the problem here is, I think, yeah, we actually want the last, I think this one here has to be masked, because we're going 8 bits, 16 bits, it's 24, 32, and then 40, but we don't want 40, we want 33. So to go from 40 to 33, we need a bit mask of 0x01, so that's the mask is like whatever. I think that's it. No, still wrong. Shit. Yeah, this binary stuff. Somebody who's, yeah, God, my expertise is really hitting the limits here. Need to shift that first. Alright, that's what oh, 8, 16, 24, 32, 40. It's been a bit too long since I did this. 33 bits is going to be from the like that. And then do it again. So what we're going to have is when we actually encode the 33-bit integer, we're going to have 8, 16, 24, 32, but it's not, it's actually going to be 1, 9, 17, 25, and then 33. So those are the bits. So and then in this example, this is our buffer. And this can have as many more, like we don't know how many more. So to encode the 33-bit integer, or rather to put it into an existing buffer, we're going to have, we want the first bit out of the PTS to be put into the, actually the last bit of so we want the leftmost bit of okay. So we want to be we want the, let's get this right, so we want the left this is actually our PTS. So here we're going to have 1, 2, 3, 1, 2, 3, 4, 5. I'm losing it here. I'm losing it. This was so easy a couple of days ago. Totally losing it. So our that's definitely what we need. That bit's correct. The end goal is basically to have this package be able to essentially encode or modify existing messages in existing playlists, for example. So if you see the background page, we're going to have here's a playlist with a bunch of video files. So this is HTTP live streaming. So we're going to have tags. Video files are actually played by the video player. What we want to do is have our package to be able to read or insert or modify these base64 encoded SCTE35 messages. So we want to be able to take a playlist, maybe remove advertisements, for example, or add stuff in. So it's to signal ad breaks, or any other kinds of breaks actually, yeah. All right. Okay, so we were up to, let's close that, and we'll also close that. So we were up to encoding the timestamp again, because this thing is just causing, well, this is going to be problematic. Okay, so we're learning, anybody here, I hope you're learning like me about how to encode these types of data in binary. It's, yeah. Good fun, good fun. So we're going. So this is unexpected. I'm wanting to get a much bigger number here. So what I'm expecting here is pretty much expecting to get all that. Mm. 0, 1, 2, 3, 4. 0, 1, 2, 3, and 4. I need index 0, 1, 2, 3, and 4 because I need 33 bits. So here is 8 bits, 16, 24, 32, 40. What I really want is 33. Oh, have I done a have I run off the end? No, but then I'd get a. No, we're okay, I think. Yeah. Yeah, source to dest. Okay, that's right too. Yeah, me too. I'm missing something here. I think it's funny because it all seemed to make sense a couple of days ago, but the weekend happens and you come back and you're like, what is this? At least that's how I feel. Let me print out this. Yeah, this is, yeah, there it is. Okay, so we want, oh, hold on. There, that's it. So what's happening is that when we, yeah, so if I do this, yeah, there we go, I think, maybe, almost. But, okay. Yeah, so, you know, VDM, you were right, we needed to bit shift. So what we're going to, yeah, so this needs to be shifted, I think. Yeah. Yeah, it needs to be shifted by, as you said, I think, yeah. Almost. And then, or 30, was it just 33? No, ticks. So we've got those there, and we want to throw away 1, 2, 3. That's right, yeah, we want to throw away those 3 bytes. So that means the one, 2, 3, 4, 5, 6. It just ensures we've got the max value, but I don't really want to do that. I want to 4, 8, 12, 16, 20. no, so they're really getting stuck on this. Very stuck. All right, so we get that is indeed the, so we're definitely passing in the value that we expect as the maximum. And then what does that look like? Oh no. And then, okay. Yeah. But I need to that's here. Those tests, yeah, okay, so what I should do is just limit the test output because the only test I want to run is, right now anyway, is this. So. This is it. I think I shouldn't be. Yeah. Okay, I think I know what. I think I want to. So this is going to be the value. If I do this. Here, there, get this really nice and small. Okay, so yeah, so there's all my 33 bits. There's a 64 I want to get rid of. So yeah, the value that I actually want to encode is so is this going to be, yeah, so like this. Almost. Oh no, we've gone too far. No. This again, hold on. And then yeah, it's like this. Ready? Something like this. There we go. Yeah, okay. There we go. There we go. Oh, God. Oh, thanks for yeah, thanks for joining us. Yeah, I don't even want to know what time it is in the UK. I guess it's really late. I guess. Oh yeah, 2, 3 a.m. So what's the time? Say London. I guess. I don't know. Yeah, just use. Oh, I don't know. For viewers of Lady Next Door, Madison Kana has 10 times more. Hey, VDM3, thanks for your help. Okay. Um, we're just checking out data F3L, data fells recommendation. Let's see. Okay. Yeah, well, man, look, it's hard. Like, it's stuff that you never think about, right? Um, no, it helped. Don't worry, it helped. Otherwise, I would be here for a lot longer. See you next time, mate. Sleep well. Stay warm up there in the UK. It's cold. Okay, so I think now we could. This, as always, this fucker right here took a long time to get. Is how one can build an audience on Twitch if one is not a female. Hey, look. We have a couple of people watching here. Like, why? What more do we need? This is just better than normally. So let's put it this way. Normally, what I do is that I write all this stuff, and then I have this one friend of mine who's like, he's a great programmer. So I just text him. I guess part of the reason why I'm streaming now is because I felt really bad that I kept messaging this guy because he's got a job and he's busy, whereas I'm just kind of hacking on stuff. So I just want to say thanks to everybody here for helping my friend out so that he doesn't get spammed all the time by me. You're doing him a really good favor. Okay, people. So let's finally go back to our big bad encode splice function. Where are we? So encode here. Is there a trick to audience building? Oh, you're asking. This is. I created a Twitch account 1 week ago, so I have no idea what I'm doing right now. I'm just, yeah, I, I'm no way an expert. I don't know anything about all that. I've never been super popular in real life either, so. Okay, so let's okay, let's now finally append our PTS. So first up, let's extend the buffer by and then we're going to put in from where are we up to here? So sorry, missed something here. Let's go right back. So what we're doing now is we're going to append our, no, not append. We need to get that byte. So first, let's append the encryption info to the buffer, because we're done. Great. Next, we're going to extend the buffer. By 1, 2, 3, 4, and then we're going to put our PTS in there. I'm going to go from the three, so that gets us to from 4 onwards. Run all the tests now. And see where we're up to. Now what I want to do here is check the value of the tier. So we're expecting, oh no, not that test, we want so the value that we want here is OXOFFF, and looks like we're not getting that. So let's see what we are actually putting in there. Well, let's see the value that we're getting first. Let's do that. Okay. I see what we're doing wrong here. So what we want to do is pack each byte in. So if we go back to tier, yeah, here we go. So what we're going to do is we're going to get our tier. So it's 12 bits. So our first oh, there's going to be that. Is that right? And then the next one is going to be, now the thing is that that's actually packing 16 bits, but we only want to pack 12. So what we want to do is actually we want just double check what we need to do here. So we're going to have CW index, and then we've got, yeah, so like, yeah, this diagram here. Let's check, we can see that. Yeah, okay. So we're gonna, yep, so coming back to here, so we'll fill up the first byte, and then we're gonna fill up only 4 bits of the next byte. So something like that. So we're gonna, so that's the pen unit 16. Do this, get rid of that. No, we will. Let's just pen it 1 byte at a time. Keep it simple. Nope, not quite. this seems correct to me so far. Oh no, not quite. So where are we up to? Where are we up to? It's here, right 4 bits of a command length. There. FFF. Oh yeah, no, that's yeah, this is right. Great. Okay. Great. Yep, we're good. We're good. Okay, so next up is encoding our command. Because we're getting, yeah. No, that's. Hold on. Why are we getting extra? Why are we getting? Like, look, that looks correct to me. Yeah. So that, and all right, let's put it here. Oh no, we are getting extra zeros. Yeah, probably, yeah. We've got a few too many yeah. Yeah, I think you're right. Yeah, I just want to quickly try this. So 4 to oh no, that's okay. We can just do the slice. It's fine. Let's print out our buffer at this point. We're getting way too many zeros here. Way too many zeros. So let's print out the buffer again. One, 2, 3, 4, 5 bytes. Are we setting this incorrectly? That's it. So this should be 0, 3, 4. That's it. Off by 1 right at the very beginning. See, so yeah. Like that. be somewhere else, but we'll just check. So 0, 1, 2. Let's get rid of this. Let's get rid of that. Setting the as a constant, that's a constant, 2 bits again. Yeah, it's in the first byte. Next byte's there. Protocol version is going to be at index 3. Let's just double check. 0, 1, 2, 3. That's at index 4. So I'm off by 1 again. Think. Oh no, 3. Wait, 1. There's a pen. Off again. So we're going to go. So the table ID is, here we go. So table ID. Next byte contains the syntax, private, subtype. That's 4 bits, and then 4 bits of the section length. So we'll just do slen. Next byte is also slen. Byte 3 is a protocol version, which we've got here. Encrypted packet is going to be at index 4. Oh, okay. Yeah, it could do. I think, yeah, I think I'll try that. Let me just finish off this where I'm counting here, because I see the issue that I've got is I'm adding an extra byte in here somewhere. I'm not quite sure where. At least I think that's what's happening. 1, 2, 3, 4, 5. It's a byte, and then yeah, and then I'm getting that 5. So CW index is so weird. Encrypted protocol versions 4. Yeah. 3, 4. And that there. So at what point are we getting too many? Well, let's see now that we've got the let's print out a buffer there. So by the time we've, let's check. The CW index is not set. Okay, so let's check what we're expecting here. Okay, there we go. All right, found it. So God, I hate this protocol. Okay, so this CW index should actually, CW, where is it? So in the sample that they give us, they, in the example that they give us, they've set, they've actually set CW index to 255, but we haven't set that in our test. So here it's actually going to be like that. And then, yeah, see, and then, oh yeah, we get quite a way of the, yeah, that's it. Okay, so that's our first thing. We need to fix the decode now as well, because there's a problem with probably where we're doing our test, we're not expecting a CW index. So, oops. Okay, so because the spec is saying, yeah, so this needs to be .cw index equals like that. This, I think. And then again for our second example, so this CW index is going to be that, and that should be right. Yep, great. Okay, little things like that. So let's go back, let's get rid of our debug print. Let's close that up. Yeah, awesome. Okay, so we're getting quite a way along. Zero, 5. So command length. Okay, let's check how we're encoding this command. Just realize that we can actually, we've done that one. Let's move on to, yeah, encode command. All right. So just as a review, the encode, our commands, well, in the Splice struct, we've got the command which actually like tells the equipment what the thing is actually meant to do. So is it meant to be a break, or is it meant to be, we've got a bunch of command types here. What are they? Command type. Yeah, here we go. So these are the command types that are possible. So splice info, where we know that we're encoding the tier correctly now, so now we move on to command. Let's see if we're encoding that okay. In the example that we're doing right now, we're doing a time signal command apparently. So there we go, time signal and encode splice time. Let's have a look at that. Encode splice time. Haha, recognize this? So okay. The PTS. Let's see how the command is represented. Oh, we're missing the splice command type. Oh, does this cipher fit into 6 bytes? Fits into 6 bits, yeah. From another stream. So I don't understand. I got a message from another stream. Okay, let's put in this command type. I just got from another stream. Command type, there we go. Oh, no, not. Oh. For another streamer asked me to go there, which is not introduced. I don't assume she paid the platform for viewers or something. Oh, right. Yeah, right. Maybe if you follow somebody. I actually don't know how Twitch really works. I don't quite get the whole following or subscribing or, yeah. So the way this is encoded is we throw in the command length, and then we throw in the command type, and then we throw in the encoded command. So that should get us a little bit closer. Oops. Excellent. Got the correct length now as well. So 0506. And now we go to a command. So something is up with the way we're encoding out this time signal struct, which is somewhere around time signal. Okay, so it's a splice time, which I see that I'm getting here okay. looks like the first byte of the of our splice time is incorrect. So sorry, splice time. Let's find this function, encode splice time. Okay, so pretty simple. We're just one, 6 bits reserved. XML. Oh yeah. It's yeah. It's awful. It's, as I said, like it's originally used by like they would somehow send these messages to like cable set-top boxes. So I guess we're talking 30 plus years old, yeah. I think the date of the release history, here we go. Yeah, so the first spec was released in 2001. Good stuff. Okay, splice time, yep, okay, and then we leave this 6 bits alone. So what do we got here? PTS. Seems okay to me. I mean, so 0680 instead of FE. Wow, it's a big difference. This protocol is still used in HTTP live streaming or HLS. So even on Twitch, for example, when you're watching and there's an ad break, I'm pretty sure they use SCTE 35 to signal that. If they don't use it right here at playout, they probably use it server side to insert stuff. But yeah, I used this, I used a package from Comcast that Comcast developed, open source one. But when I was using it, I thought, well, like this thing has way too many lines of code, and you know, I wasn't really happy with the way it was tested and stuff. So I just thought, hey, like why not? If I think that one sucks, why don't I try and do better? And this is the experiment right here that we're watching now. So we'll see at the end if how different it is from the from that original one I used. Yeah, so just seeing here 72BD00501. Yeah. So the time specified flag is 1 bit. So FE is an 80. Oh, again, is this bloody like these 6 bits? The value of those 6 bits, I think, doesn't matter. applications of this. Are you asking what applications could use this this software? Yeah, so this is used, so I'll just go back to the, so just a really quick example, I guess. I'll just quickly sketch one out. So how this is used is, so let's say you've got a TV show called, what are they called? Whoop. Okay, we've got a series called, they've got a series of, let's call it episode 1. And you've got your, let's say you've got your, oh, that's a very, this is a phone, okay. So how this SCTE35 is usually used is you have this thing called a playlist, which is used by by browsers, apps, TVs, this sort of thing to stream video content, like YouTube, same thing. Oh, YouTube uses a slightly different format, but it doesn't matter. Your player will actually download each of these files one at a time. So as the show goes, it'll play each of these video files, these .ts usually. Now, at some point, whoever is serving this stuff, so let's say you're a big company with a big building. Those are windows. What they'll often have is like an application running that will take the original playlist and actually insert ads in here. So they'll take a playlist, put in a SCTE35 message, and then at some point further down the chain, or maybe even, I can't quite exactly remember now off the top of my head, but the idea is that any bit of software that's reading this will be able to see this message and then go, oh, okay, I need to insert in an ad. And what inserting an ad in really means, right, is just putting in a different video file. So here, let's say you put that in there like that. This is an ad, and so then in here will be like ad1.ts, and then in here will be ad2. That's how it works, because oh well, that's it. Does that kind of make sense? Well, this package could be used to block ads. It could be used to insert ads. It could be used to change the duration of the ads, for example. But this in itself is really just a library. There's no application here, not yet anyway. This is just a library to encode, decode the messages. I wrote, for work, I wrote a bit of software that read in, would basically calculate durations of advertisements, and it would add in things. You could also do things like, you can use this to signal breaks, not necessarily just ads, but things like news reports. So you know how you'll sometimes have like an urgent news thing, and it'll just pop up and it'll be, breaking news, it's raining or whatever. SCTE 35 is also used for that. So it's just to, so that's an example of like the application of a library like this or a package like this. Just double checking that the command length that we've put in there is actually correct. So lots of stuff here. Splice. Here we go. Splice command length. So I'm just going to. Yeah, you could use machine learning to block ads. Yeah, I guess so, yeah. Tricky thing is when it's a live stream though, like what do you put there instead? Sometimes there's no content on the other side. Yeah, but the idea really here is just to learn and learn about binary protocols and also a bit of software engineering stuff, like for example, I know that that Comcast package is used in production environments, and I think, well, geez, it's not great software. It's not bad software, but it's also not great. So, as an exercise, just for like learning to do software engineering, not just programming. Like, we can all write code to get something working, but there's a whole bunch of other stuff about having things clearer, having things small, easy to maintain, documented, testing, all this other stuff. And I just happened to choose this protocol just because, well, I don't know why. I guess because I just had personal experience with using some software that I didn't really think was good. So this is kind of like scratching an itch, even though I don't care about ads or anything. I hate ads, right? Like I pay for stuff so that I don't ever see ads, that sort of thing. I don't even watch TV. I don't actually own a TV. I don't really watch any I don't really watch any long form stuff anyway, so yeah. All right, so let's where was I up to? So that's here. Sorry, where are we up to? Oh yeah, we're just doing this. So we're still testing encoding the splice info here. So still up to here. following the splice command type. Okay. So it's excluding splice command type. So that means that we're all good to good stuff. So I feel like there's may well be some bits in here. So what we're working on is encoding a splice time. So it consists conceptually of three parts. We've got the specified flag, which is just 1 bit. We've got 6 bits reserved, and then we've got we've got 33 bits of the timestamp. So looks like the value that we've actually got in the sample is giving us OXFE. So we're getting OXFE, and that is 1111 1110. Yeah, that's right. But we're actually getting 1, 3, 2, 3, 4, which is OX80. Okay. And these 1, 2, 3, those are the reserve bits. This is the flag, and this, and then all the other stuff is the timestamp. So it looks like the reserve bits need to be set to, looks like it needs to be set to okay, so in here, when we encode a splice time, we actually need to set those 6 bits to 1, which is, okay. So we need to set that to, well, actually it'll be just this. Let's do it in 2 hits here. And then toggle 6th reserved bits. That's X. So now we need your Tetris game. So what I want is I want 0, 1, 2, 3, and then 1, 2, 3, 0. So what's that in hex? That's X3E. 7E. Nice, thank you. Oh, beautiful, look at this. Okay, great. Look, so we're going OXFE 72001. Okay, great. So let's just double check our length here. So we got So we've got the length as 05, the command type, and then 1, 2, 3, 4, 5. One, two, three, four, 5. Okay. Fantastic. All right, now we go to encode splice time. Encode the descriptor. So this is a big hairy function. Encode Oh no, it's easy enough. So let's have a look at the Splice descriptors section. Tag length ID, tag length ID. Oh, that needs to be big endian. Oh wow, we're getting pretty close here. Anyway, ID and then data, which is just all of that. Now, in this specific case, the descriptor that we're encoding now is of type segmentation descriptor. So what we'll need to do is double check that that's being encoded all okay. So what we're doing is we're calling the data method on the Splice descriptor, and since this is an interface, we'll need to go down to the segmentation descriptor and look at that yucky data method. Okay, now before we do that, I'm going to go to the bathroom quickly and take a very quick, just 5-minute break, because, yep, it's time. So I'll be back in about 5-ish minutes, shouldn't be too long. I'll turn this off. Hello world. Hey, let's get back to where we were. I just very quickly ate something and now I warmed up my coffee. Let's go. So what we're doing right now is checking how we're encoding this segmentation descriptor structure. So I'm going to look at, find this segmentation descriptor in the spec, which is somewhere around here. Splice descriptor. Here we go. Okay. I'll just move that over here. Like that. Does that work? Segmentation. All right. Now I can just have that up at about the same time. Okay, so actually let's have up our segmentation descriptor here. There we go. All right, so when we descriptor data, now data includes everything from segmentation event ID onwards, because we've got the tag and the ID there, and then the length we do when, yeah, that's another time. So that's a straight 32 bits. And again, okay, so already I can see a problem here. I think 0, 1, 2, 3. Oh no, that's right, yeah. Okay, so let's check our bytes and see what values we're getting. Five, 6, 1, 0, 0, and 0, 1. So far this seems okay to me, so we set the cancel, we set the compliant, the next 6 bits are reserved. We set some more flags. So we go, if this, yep, we always assume program segmentation is true. Segmentation duration, yep, next bit along, delivery restrictions. Bit shifted 5 along, yep. set the actual restrictions here. You're going down, right? So then if the duration need 40 bits this time, so that'll be from, looks like we're missing a byte here. Missing a few bytes there. So what we want out of here is 5 bytes, but that's 0, 1, 2, 3. I need this to be 5. Let's get going. So the UPID type is a single byte, that's easy. The UPID length is, oh yep, from the value, so it's just the length, that's easy. Type ID. Okay, we haven't looked. Let's look at that in a bit. First up, let's get our duration correct. So if there's no duration, then we're never going to append any 5 bytes at all. So then in this case, from here, let's see where we're up to. Let's print out our buffer. Ooh. Oh, that 43E, okay, so 48 is 0, 8E, and then F. Ah, more reserved. Oh no. Okay, so what we need to check is if the restrictions are really set or not. So what I mean by that is let's check the spec and just confirm that in our sample delivery not restricted flag is 0. So that means its delivery is restricted. So, and then that's why we have these flags. Yeah, so we've got, so let's, so delivering, okay, no regional blackout, archive, and device restrictions is 3, which is the same as none. So so that's all right. Let's go back to the spec, Splice descriptor, segmentation descriptor. Okay, so we're getting here the 48.8E, that's the event ID, and then we set, that's the event ID done. Now we're setting some flags. So we get 80088E. Okay, now we're getting different flag sets. So in what we're getting is, so we want 7F, but we're getting 40. So this byte here encodes A. Oh, again, it's the reserve bits. Ah, these reserve bits. I thought that'd be 0. Okay, so that means that I'm pretty sure, right? Because we've got 7F 40. Yeah. Yep. Start again. Okay. So next 6 bits are reserved. What that really means is that we want to go sorry, no, we want to do like binary of that, which is x, so 1, 2, like that. Yep, there we go. Next 6 reserved, or the remaining 6 reserved bits. Right, another bug down. Okay, the next byte is going to be whoops. So the next byte, 7F, CF. So this time around we're getting CF. Sorry, we're getting EF, but we want CF. Plan is to resolve the whole program with a single unique test. Yeah, I know. It's yeah. It's a bit of a problem, I guess, because yeah, a good test here would be to encode a segmentation descriptor rather than testing all this other stuff. Certainly one of the problems here is that we I'm going through, like, I'm looking at the whole thing and then going along. Yeah, I should really be able to test the encoding of these things. I guess it's tricky because the only known good encoded values that we get are the whole entire splice info. So this is the only thing that we're ever given. Yeah, so there's a few other tests here and there, but yeah, certainly, yeah, we added a couple of little tests. Yeah, this is probably a good time to do a big one. Make up our own examples. Yeah, but then you don't get these little things like the reserved bits. Yeah, I guess we just don't know how to make the examples yet. That's the thing. Not quite yet. EF. But yeah, I see what you mean. Now would be a good time to do a test, so we can actually test the how to encode this stuff, because this we can definitely test. So let's yeah, let's do that. So we could do just in this file, I guess, although it's getting a bit big. Splice scripts test. So in this one we've got 11001111. So what we're going to be doing is encoding the well, let's say we get a segmentation descriptor, so let's just call it D. And we're going to have station duration. And then we want the inversion and then delivery not restricted flag. So 1, 2, 3, 4, 5, 6. Let's check it again. 1, 2, 3, 4, 5, 6. Yep. Okay, so if I go to the constants, go. So in this example, you know what, we can actually let me get this right. Okay, what we're going to do here is instead of copying this stuff out, we're actually going to get it from the sample. So we're going to go to we've already defined all of these, so we can just pick the little bits and pieces that we want to decode and then see if we're getting exactly the value, encode, and then check that we're getting the exact value that we know we should get. So let's do it like that. So we're going to go samples o dot want dot script o. Oh, just like that, yep. If I go back to our test output, yeah, we want actually CF. What we're actually getting is going to be something out of here. So one of the things we could do is we could start ripping out some of these and putting them into their own functions just so that it's easier to test. So d.duration, restrictions, just that particular byte. Let's do that. Actually, no, we'll keep that print there for now. So here we could even have a new function or something, maybe something that's like encode the, what we call it, but it's really the flags, yeah. hard to get it out, that's all. I don't really... descriptors. So that. Oh, if this Splice descriptor. Okay. So we're going to have to do a type assertion on that. So we're going to do this dot to the address to it. Yep, there we go. So that should make it easy to test. So we've got here probably something to do with the restrictions. Auxiliary not restricted flag equals 0. So that's if the restriction, if there are restrictions, yeah, and then we're probably getting our bit field incorrect. So if we go to all right, let's check this again. So web delivery allowed is going to be the bit 1, 2, so let's check this again. byte diagram, so 1, 2, 3, 4, 5, 6, 7. Progseg. Have I got this ready? No. Okay, so I think this is not sure whether we've got our constants right, so assume this is always set, so that's shifted 7, 6, 5, 4. No, that's right, yep. 3, yep. 2, yep. And then these things, so that's 0. Yeah. Okay, let's check the device restrictions. There we go. Web delivery allowed. That's funny. Yeah, it seems to be. Two bits. So it's just something to do with this web delivery, I think. Because we've got the. So here's the device restrictions. So this device. That's that bit. This is archive. This one is blackout. So range black. Yeah, so that's the byte all there. So we got shifted 1, 2, 3, 4, 5. Seven, 6, 5, 4. Now what we want to do is just check that we're actually expecting the correct thing. So the delivery, maybe we've got a double negative thing here. So if the delivery is not, so the delivery not restricted flag is 0, that means the delivery is restricted. But then in this case, this has to be 0, I think. So we should not set that bit. Yeah, that's it. So we'll double check up here. So the segmentation, if the cancel indicator is 0, yeah, so this is wrong. So this needs to be like this, else like that. think. If the delivery is not restricted, so delivery restricted, not equals 0. Okay. In our test here, we've got the rules as being the delivery not restricted. Okay, so whatever. Web delivery, no. Regional blackout is toggled. Archive is toggled. Device restrictions are 3. And that flag is also set. So, shit, seems device restrictions are 3. So maybe oh, I think we're good because our test is actually passing. I was focusing on a failure, but actually I think we're good. Let's have a look. So we've got Splice descriptor. Yeah, we're good. Okay. So we can actually put that back to how it was. Yep. Great. So what it was just this double negative confusing thing. So if the delivery, fuck that thing, it's so annoying. If the delivery is not restricted, then so restrictions, yeah. All right. So let's take those flags. Easy. All right. So let's do that. Okay. So from here we can get the seg. Splice descriptor, and then we can start. Now we can just use our function in the method just to make this a little bit shorter, which is always good. So we can actually just go so we can just go like this. Oh, I just realized I was writing everywhere and I wasn't showing up. Shit, my bad. Anyway. Easy. Oh, bang. Oh no, sorry. No, got too excited there. There we go. So CF, awesome. All right. Now we're going to go and get the duration. CF, and then, yeah, it looks like we're not doing that duration correctly. Yeah, okay, so this is wrong, right? So what we actually want to do is get those values. So we can do we can just shift the whole thing along and encode it like that. So we're going to do so that actually shifted along 8, 16, 24, 32. No, almost. 24. Oh, of course, yeah, 24, because we want 40 bits. So there we go. Nice, all right, here we go. 2 CA, 0, 1, 8, 0, blah, blah. Oh, so close, so close. Okay, a few more bytes left. We got, oh, looks like we got an extra couple of bonus bytes in here. So 0200 and then 9. I'm going to check this UPID thing, UPID. So segmentation flag, okay, segmentation duration we're also getting correctly. So 00, yeah, 1A599B, blah, blah, blah. Yep, awesome. Oh, shit. Okay, so the UPID type this example is the TI apparently, and then the identifier is those bytes. So one. Oh, okay. Well, how's that for a start? So we've copy and pasted it wrong, I think. 18A. Oh no, maybe not. Oh no. Okay, no, we're actually getting that. Okay. So we're going up to 18A. Okay. So the next. Okay. So we're doing the UPID. Okay, as well. So looks like we're okay, so then we do a few bytes. So we go 18A, go 3, 4. Next byte is the number. That's 2. We expect 0. And then we append the, okay, here we go. Here. And then we're getting some zeros extra, but we don't want them. Yeah, I ran into this before. So this is actually, yeah. Okay. So we only append the sub number and sub expected if this is greater than 0, because we're not expecting any segments. So then there can't be like a sub section of them because we're not expecting any. I think is the way the logic goes. It's not super clear, but that seems to be the case. So let's actually write that down. So if then we append those. Okay. Got the correct number of bytes, and now we are, what's the last bit? So okay, well, we're encoding the Splice descriptor, okay. The segmentation descriptor anyway. So now it's finally just this checksum at the end. So let's see where we're going wrong there. So that's in our Splice info. There we go. Oh, that's decode. I thought that looked weird. Okay. Encode. No. Yeah, okay, here we go. Could be that we're not putting in the correct value for the buffer there. It would look like, yeah, it looks like we're sending in the wrong, or yeah, because I have never modified this function, never touched it. So that sending in the wrong thing to checksum there. So we'll go to our Splice info and then just check what that checksum is actually for, or rather what it has to say about it. Expected, oops, sorry, I went past it, so CRC. Prior to decryption errors, no, oh man, this is a 32-bit field that contains the CRC value equals 0 for the registered decode environment, which includes the table ID field through the CRC32 field. That. After processing the entire Splice info section, including the table ID field, through the CRC32 field. So does that mean that, do we need to do it twice? So we need to get it, like, include itself in the sum? So uint32 is going to be 4 bytes, so that's 1, 2, 3, 4. So we're getting, that's the value that we were getting, but what we want is like 9 AC, 9, blah, blah, blah. Yeah, so totally different. Yeah. 1, 2, 3, 4. Sure, how to calculate this thing. Maybe yeah, this is interesting. So I just realized I've got the YouTube chat closed just in case anybody's speaking there. Video for day one. Oh yeah, hi Sang Tan, is that how you say your name? Sorry if I got that wrong. Day one video is gone, sorry. It expired on Twitch. That's the only place where I kept it. But yeah, sorry about that. I'm thinking of doing like an intro video. That's probably helpful so that other people can watch it. But yeah, sorry, don't have one. Don't have day one. All right, damn, yeah. I wonder if I need to do the whole thing twice. Like, do I need to do... Just, I don't know if it happens, right? Because, no, because blah, 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 oh, buff, yep. Oh yeah, cool. It's gonna be too many. So do I need to? Yeah, no, I can't possibly. Maybe we can do something like this of the and then that's going to be the CRC 32 of, yeah. Is this even possible? Is this? And then finally, oh no, we've already appended it there, so how are we going to do this? Oh no, yeah, that's okay. And then finally we do it again, but this time we just grab the, like that, CRC, and then return, something like that. I get 0. Oh, that actually seems about right though. Like something, they did say something about the 0 output of the registers. So this like zeroes itself out or something. CRC 32. Well, this is a good idea for a test. Because what we can do is, we know the value that we want. So CRC 32. much right on the money. Pretty much. 1E, 0, 2, 1R, a few little bits and pieces, but you know. Ah, man, what is that checksum? I think no, I'm going to have to leave that. Not quite sure what's going on there. So there's a few other bytes that are, I think, are not correct here. 0, 2, E02 there. 8 instead of C. 435490087 FCF. Yeah, that's the only bit there. Okay, so 0, 5. So it's Splice info. Oh, the length is wrong. One byte short. Check whether the buffer length has to include the CRC32. Right now we are not getting that. So let's go to Splice info. So we'll get this section length. Could be the alignment variables, we'll get that. Up to the end of the Splice info section. Okay, there we go. So but then the length to including this, how can we append it if we don't know the you know what, this is probably where we're getting the problem anyway. So it's got to be that. No, we're way out then. Where did we lose a byte? right. Okay, so now we're actually getting the length correctly, so that's good. And then, oh no, sorry, no, the section length is 52. So it's 3 bytes. What? I don't get that. Command length is 5, section length is 52. No, okay, so it actually goes like that. So let's see if we're getting the correct thing here. So this should be 52. But I don't think we're going to get that. 51. Okay, so we are a byte short. So, woohoo, boy, oh boy. Three, 4. And yet the weird thing is that we're actually getting what to me looks like the correct number of bytes. So the length that we're encoding into, yeah, the length that we're actually saying is there is not the case. But it can't. So if we took away the 4 bytes here, 1, 2, 3, 4. 1, 2, 3, 4. B 0050001 EO2 on 8. It's got to be there then. E7F-C-F-0-1-8-5-9-B-0-8-0-2-C-A. Oh man, do you hate that? We're 2 bits off. 2 bits. Yeah, so we've got 1 bit in there that's not right. Yeah, so as Data F3L was saying in the chat, yeah, it would be a good idea to like kind of get the sections, like a little diagram that sort of, you know, gives you the sections and goes, oh yeah, okay, so that's that section, that's that section, just so that we know like where we're off. I know, I just remember off the top of my head that that's the tier, but another way to do it is just print along the way. So let's go here. So everybody loves a debug printf, right? It's a little bit further along, so we're encoding the command okay. Yeah, So that's all good. So our problem is going to be when we encode the splice descriptor. Yeah, I think so. Encode splice descriptor. What's that? 218 there. That's it. Okay, all good. So let's actually print out that. Yeah. Okay, so we look at our segmentation descriptor. So the second byte. Yeah. So it's the first nibble of the second byte. Yeah, 21. Oops. Shit. No, I'll just run it again. 21. Yeah, so yeah, okay, there we go. So the descriptor length is wrong. Let's go encode splice descriptor. Length of the data. So the length of the data is wrong. So in our data method, it might be print this out. The value that we should be getting is 21C4, so the value that we really want is oh 0218 021C. So I should be getting 1C. So which bit am I missing in here? Or which byte? So this, the descriptor length is maybe something else. So let's check exactly what they mean by that. Something else can form an optional appendix of the segmentation descriptor. Following this field. So following the descriptor length is we've got the ID. Okay. Oh, whoops, no, we want .24. Okay. O21C. Yeah, okay, so we're 4 bytes off. So something in here we're missing. It is going to be that identifier, isn't it? It's going to be that we're not including, yeah. So the length is, okay, whew, man, these things are tricky. Okay, so at least I find it hard. Okay, so it's the length of sd.data plus length of sd.id of length. Oh, okay, plus, okay, 4. C. Okay, great. We got that bit correct. Now we're going to find out how come we're missing a byte in there. even though 2C A0A18. Okay, so maybe it's something to do with the. There is something weird here in the splice info. There's this alignment stuffing, and I haven't looked at that properly, so that might be significant. The thing is that I would expect have a look again at this alignment stuffing. When encryption is not used, this valid shall not be used to carry valid data, but it may be present. Two. We've got everything is correct except we're out by 1 byte. It's really just 1 bit. So what if, okay, let's just +1, just because no reason other than to get to 34, and then see what the CRC32 is for that. Magic might happen, who knows. So if we go to splice info, yeah, and then we go to length, and then let's go like, offline ++. We got it. And the CRC32 is correct as well. So we got it. I just don't know why that's why that needs to be, why the length is 1 more than what we end up calculating. I feel like yeah, that's kind of scary, yeah. Now, to be fair, in our next example, in our next test, the length is always needs to be +1. So we're kind of missing a byte. We're always missing. We're always one down. But that could just be a coincidence because we're not exactly sure that we're encoding this splice insert correctly. Now, you know what the other thing is that, oh no, yeah, sorry, yeah, section length, yeah, 52, yeah, so we're definitely down 1. But the decoded length, I think, is actually correct, so let's just check that. So we'll do this, yeah, let's go to our test, and 50. So the decoded length should be 50, but we're getting 55. Sorry, the decoded length should be 55 and we're getting 50. So that's interesting. Oh no, sorry. No. That's only for. No, that's wrong. That's only because that test is failing. But so log only prints something when. Oh, the t.log will only print something when the test is failing. So what have we got here? 46, 51. All right to me. Oh no, again we're no. Okay. Let's do it right here. Yeah, okay, great. So we're all good there. There's just, that's fine. Let's have a look at Splice insert now. So Splice insert is a different kind of, where is that? All right, here we go. So we've just done the time signal command. Now this time we're going to do a Splice insert command. So let's have a look. So the info, encode command. That's where we want to go. What I'm thinking is that we'll just instead of doing like what we did last time, let's just like hammer away on one particular part of the message. So we're going to find where the insert command is in here in our slice of bytes. It shouldn't be too hard to figure out. We'll just need to do some counting, and I can count, we can count. We're well qualified for counting. So we want the tier is going to be the F's, F, 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 and then the command length is 12 bits, so, and then so 4, 8, 12. Command type is that apparently. Let's check. Yep. Okay, so the insert command is going to be 5 bytes. That's what it's saying, isn't it? No, the command length, sorry, no, is 1, 2, 3, 1, 1, 4, and then the type is 05, so the length of those. So let's go here. 014 is an octal. So we'll go 1, 2, 3, 4, 5, 6. Okay, now we've got a test running. Let's do it. So segment we've done. Oh no, so no, way up here. So command, Splice command, Splice insert. Okay. There's our structure that we want. It's pretty So the event ID is 1, 2, 3, 4. The classic, of course, is the toggle next remaining observed 7 bits. Okay, along we go. So we got the cancel. All right, let's check. So we're going out of network, toggled, splice time, toggled. Sorry, no, that's not right. Out of network. Program splice flag. I think, yeah, I always want to toggle that. I think. Yeah, okay, so we're always going to toggle that bit. So as I've written, we don't support this sort of like deprecated mode. So instead, we're just going to always set that, and then I'm just going to have a look at that in a sec. It looks a bit sus to me because, yeah, so that's not what we want to do. Now you know what? Before I actually do this, I actually want to make a commit because we've successfully encoded splicing for test. Okay, we'll keep that there for now. So this is, we're implementing the Splice info, no, let's just call it the command. So the command was a time signal command encoding. Oof, lots there. Okay, let's get going. Oh, whoops, yep. So we're going to go back to command, code, insert, Splice if immediate, and toggle it, yep, for the compliance, yep. Next 3 bits are reserved. There we go, there's our problem again. Hey there, Kai314, how's it going? Last 3 is going to be like that. 0, 1. No. 0, 0, 0, 1, 1. What is that? Hex. 7, yeah. Yep, almost there. Almost there. Okay, so that's good. The splice time. Now this is one of the things on the to-do list that I wrote a long time ago. Now feels like a long time ago this morning. Sketch. Yep. That's this one here. This the appending the splice time. So I want to I think I'm going to do that because the splice time is always kind of on its own, so it can just be safely appended to pretty much any buffer without, mingling with the bytes surrounding it. So it doesn't need to be bit packed. We just need to append the bytes. So I think that'll be a good, nice function to add. But maybe it's actually, no, you're not. No, let's keep it simple for now. Let's just do this and we can optimize it later. I'll say optimize. It's not even optimizing. It's just saving a line or 2 somewhere. Okay. So the splice time is 5 bytes long. So we've gone byte index 6, so 1, 2, 3, 4, 5. Oops. Looks like that's okay as well. So just turn up the buffer at this point, just to see where we're up to. Oh, too many friends going. To E, FE. All right, so let's FE, okay. So all we want is pretty much where we got up to. Is that correct? To EFE. Let's confirm again, just our test case actually matches up with what we've got in the spec, because this has always been a tricky thing. We've actually already done that. Whoops. Hey Kai, yeah, it's all right. It was slow this morning. We really got stuck on a really dumb problem, but yeah, we're sort of moving along nicely now, I think. At least we're moving along, which is important. We're not stuck. Yeah. How was yours? Nice. Welcome back from work. Oh yeah, nice. Nice. Yeah, I think you just learn forever. I don't think it stops. Okay. So let's just check. Sorry about that. I just want to check. Yeah, that's right. We're going to check that the sample that the example that they gave us matches up with what we're sort of what we're testing against. So we've got our duration. Hold on, let's start from the top. Yeah. Protocol version 0, yes, of course. PTS version is 0. Okay, we don't set it. Tier, yeah. Splice command length. Okay, we don't do that till later. Splice insert, yes. Event ID is 48. Yeah. Out of network. Yeah. Duration, yeah. Immediate is 0. Yep. Okay, auto return, duration, avails 0, 0, descriptor loop length. Okay, we'll get that in a sec. Avail descriptor. The value is 00135. And our CRC32 is 30A. Okay, that seems right so far. So let's go back and just find exactly where we to E. Let's get some nicer test output. So go to maybe 52 EFE00552 F500. Ooh, we're getting close. Yeah, we're actually pretty close there. Okay, so FFE. I'm not super confident that the value that we want is actually this, so I'm just going to try and get it again. So I remember that's the command type, and then the length is 014. So what I'll do is I will get the oh yeah, it's interesting. Jeez. Yeah, it's like a puzzle, you know. It's yeah, the actual reason that this protocol exists is super boring, but yeah, sometimes it's fun just to work on random things like this. Let's knock O2E. I'm just going to comment this out for now. So not, actually. Test encode insert. Let's just run this test. Because we're actually almost at the end of the thing. Progress is O2E, O2E. Yeah, so it looks like we're not packing that break duration correctly, maybe. O2E, O2E. Ah, no, okay, yeah, no, I know what's going on here. So here is, again, it says reserved bits. Oh no, we've toggled them, have we? Code splice time, pack break duration. Okay, let's see break duration. Yeah, okay. Okay, again, so apparently if the bits are reserved, that means they actually have to be set, not 0. So 6 bits is x3f, I think. Is that right? Because that's 6 bits is, the value that we want is 0, 0, and then 1, 1, and then 1, 2, 3, 4. So that's 6. So that's O, X, 3, and then F. Yep. Okay. O to E. I got that. Maybe I haven't got that right. 0, 0, 1, 1. Doing that now. It's a PTS. Ah, yeah, no, I got this wrong. It's actually, yeah, no, so this is actually, no, this isn't. It's actually this that we want. 2, 3, 5, 6, and then that byte, that bit is actually from the duration. Which has a whole bunch of bits. Did you find that funny? It's hard. Look, I'm finding it hard. Maybe it's just me. Yeah, I'm struggling, but it's easier maybe than it was 1 week ago. So, yeah. Did I find your comment funny? Yeah. Did you find it funny? Okay, so that is actually 3, and then 1, 1, 0 is actually, you know what? I want to write it out as binary because I think that's actually clearer. 4, 5, 6, 0. Because it is a bitfield. Oh, wow. Look at that pass. Wow, wow, wow. Oh, man. Holy shit, I did not expect that to just pass like that. Oh, God. That is, wow. I did not expect that. Whew. Shit. I don't want that. Oh. Okay, well, yeah. Just realized I forgot. I keep forgetting to check the people on YouTube. YouTube. Sorry, guys. I'm kind of confused by all the. You got to do the different things. Comment. Here we go. Live view in the live control room. Okay. Somebody asks, what text editor am I using? I'm using a text editor called Acme from Plan 9. So there we go. And then there's a really good walkthrough it's a cool editor. What am I working on? So this is, I doubt anybody's been here since the beginning, so I might just go back to the top. I think I actually wrote a diagram before, hold up. Yeah, okay, so I'll just do this again. So for anybody who's joined just recently, or in which language and which language. So far, I think the original one, I think I've linked that. Let's have a look. Okay, let me open up this page, and then I can talk about the original project and all this sort of thing. So what we're working on is a Go package to encode and decode SCTE35 messages. So this is a little binary message protocol, and all it's used for is to signal ad breaks in video players or any sort of like breaks. Try to click link to GitHub and it asks to sign in. Oh, weird, okay. Oh, yes, whoops. Oh yeah, sorry mate, there's a typo there. Let me try again. My mistake. Untangled streaming. Okay. Okay, just try that. Does that one work now? I'll actually just push this because that includes a couple of the commits we worked on just from today. Or I mean today, so from a few hours ago in Australia. Cool. Thanks. Cool. Yeah, sorry about that. Okay. So so this is a it's like a binary encoded message format basically, and when you're watching like Twitch or like some on-demand video streaming service like Netflix or Disney or whatever, what you're doing is you're reading, your video player is reading a playlist, and it contains a bunch of video files that it just plays every like 2 to 10 seconds. So 2 seconds, this video, next video, and the next video. Now, in the playlist, it's got a bunch of like metadata, which just tells, gives you like extra information about the video or what's coming up and that sort of thing. And one of the things that's in these playlists is it's not actually ext discontinuity, it's some other tag, I can't remember, I think it's like ext date time or something, I can't remember. But basically this thing has a base 64 encoded message, so it's like, A, B, C, D, 1, 2, 3, 4, blah, blah, blah. So what we're doing is, let me put it this way. So within that, there'll be a bunch of information about like for example, an ad break of a certain duration. It'll say resume playback. And that'll be at a certain time. So the message encodes that kind of information. It's binary encoded, it's bit packed as well, so it means that instead of using like 16 bits for numbers, sometimes it'll use 12 bits to like save a byte. So it's from a time, the original spec was published in 2001. And the free spec, yeah, it is a free spec. You can download it. I think I linked to it. Yeah. But yeah. Yeah, it's from 2001, and it's a pain, and yeah, it's as I said, used mainly to signal ads, and it originally was used in like cable TV, you know, like in cable set-top boxes, stuff like that. So those things had like barely any processing power. So you know, I think that's part of why this thing is so kind of efficient on the wire, and you can just calculate things just by, you know, and there's some encryption, but it's like broken encryption because it's very old. Yeah, so yeah, this is a package that just works with those things. Originally, for a real-world project, originally for TVs, yeah, actual like broadcast satellite stuff. But they still use it in like on the internet for internet streaming. So yeah, this is why I sort of, well, I originally did a project for work, and it was needed to calculate ad breaks for an on-demand service, like an on-demand, well, a whole bunch of channels in Australia where I live, where I am now. And for that, I used a package from Comcast, which is like a big American company. I think they do cable TV, but I don't, yeah. Anyway, that package was really big. I think it was over 4,000 lines, maybe almost 5,000 lines. And I think I got a link to it in the source code. So it used like quite a few external dependencies. It had loads of lines of code. The testing was, there was a lot there. So far, we've basically made a new one, and we've got a few smaller tests, although I do want to add more. That's part of what we're doing today. We've stripped a whole lot of redundant documentation that was just copy and pasted out of the spec, which I don't see any point in that, because you can just reference the section, or nothing is fine. Documentation needs maintenance too. We've removed all the dependencies, so that's cool. So now it just uses the Go standard library. And yeah, as I said, we've deleted like over 3,000 lines of code so far. Today we were just working on, where are we? There we go. Yep. So today was mainly for, the main thing was this guy here, encoding the Splice info. So we didn't actually have that working before. I'd written a bunch of code, but yeah, I hadn't really tested it yet. We just got that working, yeah, just like 20 minutes ago or something. We got one type of message working, but we didn't get another one. Next up, I guess, would be to use different samples from the spec. So they actually give you about, what do we got here, 8 examples that we can use to test our implementation. So we can go through and we can say, oh, here's a message, or here's a base 64 one, and we can try and, you know, decode that and see if we get these values. Yeah, the other thing we can do is we can try and encode one of our structures and see if we get the expected, you know, bytes out. So yeah, that's it. Yeah, that's where we're up to. It's a pretty boring project in the sense that, like, who cares about ad signaling? The next thing I'd like to, people have expressed interest in is, some people have said they want to see a MPEG transport stream package. So this is kind of like MP4, MPEG-4. It's a media container, but there's one that they use in streaming called MPEG transport stream. And that's also another old sort of weird thing, but it's used a lot. So it could be fun to do one in Go, because normally people use like C++ or yeah, there's like, I think there's a couple of bits and pieces in Python. There's a couple of open source ones, but again, I think, you know, it might be fun to try and do one that feels very more like Go. Yeah. Can we run a Go file outside of main package? Somebody asks. In general, or sorry, I'm not quite sure what you mean, Arunava. Do you mean like just running any arbitrary Go file? Yeah, you can do that. You can go like, you know, but you'll need it to be in the, it'll need to have a main function, I think, if I remember rightly. Can I rip a fart for, I don't know. I'm only doing software engineering here. I don't know if my talents extend that far. All right. So now that that's passed, let's just make sure we haven't got any debug print left. No, I'll just print this in. Oh yeah, print. Yeah, okay. Yeah, that was a silly bug, so we can just get rid of that file. Whew. You should, okay, this is just a random thing, but was it Kai314? There's a channel on Twitch where it's got like President Trump and President Joe Biden, the US presidents, and they've got this hooked up a large language model to it, and you can just type to it and it'll just kind of reply to you, and it's so funny. It's so bad. It's so funny. You can ask it questions like what you're asking. It's super funny. I was doing that yesterday. Yeah. And it's not just a large language model, it's like with voice as well, so it's got a voice synthesizer on it. So good. Okay, let's commit this thing. encoding of splice insert commands. Okay. Look at that. How is that possible? How did we just delete? I just... We've got one weird failing test here. Oh yeah, no, this is actually incorrect. We actually want this. 1, 2, 3, 4, 5, 6, there, like that. Yeah, okay. Let's just check this in as well. Whew. All right. Oh, man. Okay. So what's next? What's next? What's next is I might just get another coffee. So if you just leave me for 2 seconds, I'll just change. Yeah, I'll just do that. That's okay. Okay, 2 seconds. I'll just mute this. Okay. Hey. Oh yeah. Thanks. Yeah. I've got it right here. Oh wow, a dietary aid. Cool. What is a dietary aid at the hospital? Hospitals are wow. That's working in a hospital. Wow, that's hard. When I did a little bit of work at the hospital, I found it quite difficult. So, respect. Yeah. All right, so I feel like now now might be a good time to, let me think. Yeah, I'm just looking at so I want to work on this because then, sorry. Just move that in a bit. Essentially, I feel like working on this because I'm not really happy with the testing, like how the tests are so far. What I mean by that is like we've got these kind of big end-to-end tests, but we need some smaller stuff. Now that said, we do have a bit more of a, if I go to Splicing for test, decoding stuff we're okay. Encoding, we're kind of doing something very one thing we could do is one testing strategy, which I'm not, I could do, is say we've got a sample message. So let's say we got like a, so say we got a message, and then what we can try and do is we can try and encode it. So it gives us 0x, A, B, C. But we also know that we can decode that okay. So what we could do here is into a message. And what I mean by that is, splice info in our package. This is also a splice info. So for debugging purposes, what we could actually do is try to encode it. So step 1 would be to encode it, and then step 2 would be actually to decode it, and then we can compare what we get, and then see, we can compare the fields, and we can use these diff functions that we've written that just kind of gives us like a readable way of seeing what, which fields are different, how they're different, why, that sort of thing. This is the kind of, just the encoding test strategy. But for now, let's do another test by decoding one of the other samples from the spec. So now that we've got encoding and decoding okay, let's actually put it to the test and just try a brand new message. See what happens. So, got a bunch of tests here. Oh, sorry, I haven't got this. There we go. Yep. We'll go, so let's add a new test in here. Okay, and now we're going to turn this into like the structure that we actually expect. So I'm just going to put this over here so we can follow along. So we're going to start with, maybe, and also what I'll do here is I'll do a I'll just put this up here just so we remember what it looks like. So subtype here is table ID is constant, we don't care about that. The short section not private. Reserved OX3. This is this sub none, okay? Reserve the section length, okay, whatever. Protocol version, unencrypted, no adjustment. It's here. X there. Command length, I don't care. The command is a time signal, and it has the time field set. So just grab that. Oh, somebody's asked a question. How long have I been coding for? I think now probably about 5 or 6 years. Something like that, 5 to 6 years, yeah. And I've been doing, working with computers and stuff for about something like over 10 years now. So first half I was doing like sysadmin, DevOps, SRE, site reliability engineering. And at some point through those first 5 years I wanted to learn programming, and so I did, and it's been really fun. There's a lot to learn. Also, you can kind of write code, but then there's all this other stuff, right? About actual, like what I often hear called like software engineering. So about writing these tests and stuff like that is, I think there's a bit of an art and craft to all that other stuff as well. So should get a haircut. So that's yeah. Okay, our time signal So we're working, what are we doing here? So we've got our command, okay? So let's get our command struct, time signal. Oh, okay, that's easy. All right, so that's just a UN64. Okay, let's copy and paste this. Pretty easy. I've been copy and pasting for over 10 years now, so. What do we got? Is that? Let's check. Okay, yeah, that's all our command. Next up is the descriptors. Now, the ones we've got here are, looks like a segmentation descriptor. So, if I go dog segmentation okay, segmentation. Card 314. There is a lot to computing and IT. There's a lot to everything. Like, you know, when you start going down into, into details, it just seems to go forever, doesn't it? Yeah, yep. The cancel indicator is not set, okay? Let's see, yeah, I did, yeah. And then delivery not restricted, web delivery. Not sure about the event ID compliance. I'm going to leave that false for now, but that's usually set to true, even though they don't actually put it here. Yeah, I'm not super clear on how or why that's set. It's confusing when I read the spec. So we're going to go cancel is not set, event ID compliance we'll leave for now. Restrictions. So the restrictions here is going to be our delivery. Oh no, we can just do it straight from the constants. So that's going to be doc for those guys. And then what have we got? Web delivery allowed. And no regional blackout. And archive allowed. And the device restrictions is 3. So if I go so that's this, so this device restrictions none, so we'll do that. So we've got web delivery, no regional blackout, archive, and 3. All right. That's the restriction set. The duration. Oh no, that's okay, that's not set. UPID. Type here is Eterna identifier. Okay, so this is this UPIDTI, wherever that is. We had another one of these before here, this thing, yep. this UPIDTI, that's just a constant, so one of those things. Length is 8. Okay, the identifier is those bytes. Okay, that's actually this again the same as what we had up here. So I'm just going to copy and paste that. Let me just double check. 2C-A0 A18A. Yep. Great. Okay, the type. Type is a placement opportunity end. Okay, so the segmentation descriptor constants are in a table in here somewhere, and I haven't put them into a. I haven't set constants for them yet. I should probably do that, but there's a big old table of these things. Yeah, here we go. Okay. So we've got program. Oh shit, I've forgotten it already. Page 76. Placement opportunity end. Placement opportunity end. So there's this provider placement opportunity end, and there's distributor placement opportunity, whatever. Add block, okay. We're going to use this one here because last time we had to use that, so I'm assuming we're going to need that one. Segment number. Okay, so the number is 2. Segments expected is 0. And then there's no subs. And then, okay, cool, yep. And then finally we've got the CRC32, which is that sort of error correcting checksum thingy. And the value is that. Okay, ready? Oh. What have I done? Command. Whoops. Like that. Damn. Okay. All right. Oh well, that's good, that's good. And see, we're getting some little bit better errors here, number 4. A little bit better anyway. Okay, decode splice info. So the index is different apparently. So maybe we do need to set that. Yeah. Ah, yeah, because they're reserved. We should almost do that in code really, but yeah. Okay, set that. Data differs. Hey there, Johannes. Oh, damn, sorry to hear. Switching to go between learning for everyone. Oh, yeah. Yeah, I mean, yeah, okay. Yeah, I mean, I think that the, why are you thinking of switching, I mean, why are you thinking of learning Go? Is there any reason, or just sick of Node.js, or curious? Looks like 53, 72, okay. So in our segmentation descriptor here, we okay, segmentation descriptor. Yeah, yeah. I believe it offers superior engineering capabilities compared to JavaScript. Do you think this switch is wise? So somebody's asking in YouTube about switching from Node.js to Go. I believe it offers superior engineering capabilities compared to JavaScript. Do I think the switch is wise? I asked, oh, well, why are you switching? And he's saying, you know, mostly because it's static typed and pretty hyped in the back-end development as well. Yeah, I guess one of the really cool things about JavaScript, one of my close friends, he's a fantastic JavaScript developer, and he's a real, you know, full stack engineer. And I mean really full stack. He'll go from, you know, he's obsessed about color palettes and stuff in the front end. You know, so he does all sorts of stuff with frameworks. But then he's also like written a couple of languages in that compile to WebAssembly. So he loves sort of playing around with Zig and C, and he's written some assembler and all this sort of stuff. One of the cool things is that with Node.js, JavaScript is probably the language he's most familiar with because of all the work in his day job. So being able to write JavaScript in, you know, that can run in a web browser, but then can also run on a server or a desktop, or, you know, even like your iPhone and stuff can execute JavaScript. Yeah, that's pretty cool. Really handy, you know, especially if you've written some packages, or you call them packages or modules. I can't remember what they're called in JavaScript, but yeah, you've written libraries to be able to reuse them with JavaScript. Yeah, super handy. Imagine if we wrote this in JavaScript. I'd really think about writing an application in JavaScript too, just so I could use this library. But we're writing it in Go. And yeah, Go, yes, yeah, has a static typing, so it's super helpful. JavaScript has TypeScript and stuff. My friend really loves TypeScript. He says, oh my God, I can't believe I didn't use TypeScript for so long. I think if you think about what types of projects that you'd like to work on, and then maybe some of the tooling. Also, for me, I didn't really pick Go because of Go. I picked it because let's say it just felt right. It just felt like, oh yeah, this is cool, and I just did it. And the same people will feel that for Rust or for OCaml or for Shell. So yeah. If you want to, if you want to do a lot of like web browser UI stuff, then yeah, JavaScript, of course, yeah. But if you really don't want to do that, then there's a lot of other languages that we can learn too. So it's more on the domain or project that we're interested in then. Yeah, I guess so, yeah. It depends, like you say, you're talking about job prospects. To be honest, I'm here in Australia. There aren't like so many tech jobs. I mean, of course they exist, but when I lived in Europe, there were a lot. So I feel like both JavaScript and Go will, I think they have a lot of, they see a lot of use in sort of real world production environments. Is there any particular like domain or projects that you're interested in? That's probably maybe that's the next thing to think about. I sort of like fiddling around with network protocols, and so to me Go, there's some great the libraries for Go and the standard library it kind of fits that really well. I think, with everything running on Unix or Unix-like sort of networking primitives, it's, things like pipes and the I/O package, yeah, it kind of fits with my brain well. Yeah. All right, so, oh yeah. Oh wow, so many people. Oh hey, I just realized there's all these people. Yeah, hey, thanks for following. There's all these people that have been following. Sorry, I'm not good at keeping track of all these different things. Thanks for following. Yeah, it's cool that we can all do this together. Yeah, it's been good. It's been good fun actually. Yeah, thanks everybody for joining. Everybody, I think we're doing well here. I think we're doing well. Ish. We can do better. Okay, so coming back to the code, to our software, the bit that we're looking at now is in our Splice info, the descriptors differ. And it looks like a flag is set incorrectly. So if I look at the segment descriptor, it's that event ID compliance again. With event ID, cancel, and then event ID compliance. All right, so we've got the data differs. Weird. So we've got the event ID. So the event ID is not compliant. But when we let me get this right. So when we decode the descriptor, we are setting the event ID compliance to true. So let's review that code. So we go here, look at this descriptor, and when we decode, okay, descriptor, okay. Weird. I mean, it's pretty straightforward, and this, it's only this one test. The other samples are passing okay. We're only failing on this this new test. So, subtest, should we say. Yeah, pretty weird. So we're checking here if the bit is toggled. So we're expecting it in the second, like in that sort of left bit, which is, if we go to Splice, infos, no, sorry, segmentation descriptor. Okay. Yep, so we're reading the event ID, then we check in the, I get this right? Yep, in the next byte if the cancel bit is set, and then we check the next bit along if the event ID compliance bit is set. So, I mean, if we go like, print that, or how are we going to do this then? Okay, one thing we can do is just limit it to this one test. Oh yeah, Rust, yeah. I found Rust quite difficult to read. I'm not a great programmer by any stretch, so I'm not like super familiar with like the sort of more advanced stuff that's going on in Rust. I've never written much C, for example, so like I've never had to think about lifetimes and sort of how and when memory could be allocated or freed. And I think that when you do think about that, it sounds like Rust is like really cool because there's some interesting computer science stuff that I'm not smart enough to really understand. And it sounds like some amazing work. Yeah, I think there's a lot of stuff, you know, like beyond the language, right? Like when you implement, say, a VPN, there's all sorts of stuff you have to deal with. That's not just learning the syntax of the language. So I'm just, for people who are on Twitch, I'm just speaking to somebody on YouTube here. They're saying that they explored Rust, but their tutorials were really overwhelming compared to coming from JavaScript. They saw people building operating systems, VPNs, networking stuff, just as like simple toy projects. And so they're saying that learning Rust feels like a really steep learning curve compared to or relative to their experience in the back-end development world. But they're saying that it's probably going to be worth the effort to learn about it. Yeah, I'm on Twitch as well. Yeah, on there we go. I'm just streaming to both at the moment, just because I don't know. Yeah. Okay. Sorry. Let's keep going. Yeah. So the only thing that's different here is that event ID compliance flag. That's the only. Yeah. So it's 1 bit. So let's run this test. Oh, no. Oops. Okay, so we're just limiting our testing just to do this one subtest, this new sample that we're doing, and then let's print out the well. Oh man, okay. I don't understand that. The event. We read the event ID, cancel, and that. I don't. Okay, let's run all of our decoding tests and see what we get. So our logic is right, but there's something. Yeah, look, I don't know about that event ID thing. In this example then, okay, oh no, okay, so in our test case, we'll set the, yeah, of course, sorry, I always get confused with this. So in our test, we're going to set the expected value of, what do we call this? Event ID compliance, which is a shit name, by the way. We should set that to something shorter. We're just going to set that to true. Oh, bang. Okay. Awesome. All right. Should we test encoding it? I think. Will this test encoding it? I can't remember whether we're doing a. Let's just do that. Yeah. Wow. Nice. Okay. So it looks like our code is getting better. Just going to test. Oh yeah, awesome. Okay, and we're encoding it. Yeah, look, we're all going. So encoding it. Hold on, seriously? It just works? Holy shit! Okay. Should we add a should we just add another test case then? Since our code is so like amazing that it just works first go. Nah, almost. Oh no, I think it did actually work first go. It was just the it's just that event ID compliance flag thing. Let's add another one. Fuck it. Here we go, 14.4. Sorry about the sunglasses. It's just the sun like comes right in here, so I'll just okay. So 14.4, the SAP reserved. Okay, so that's again that constant value. Here again is that. The command is time signal again. I'm doing one that isn't time signal, but it looks like they are all time signals, which is fine. All right, anyway, we'll do this one. Okay, so time signal type is time signal. And the value is going to be here. Oh, let me just check 14.4. Yep. So it's going to be that sort of yucky integer. The descriptors, we've just got one. Then ID is that. Oh no. Sorry, no, the event ID is that one. Okay, we're going to set the cancel is not set, so we can just leave that field. I'm going to, just so it's clear, I'm going to open there we go, just so we can follow along. Okay. Talk to my eyebrows. That's a funny username, man. Yeah. I don't know why I find that funny, it just is. Good. Thanks for following. That's hope it's thanks for joining us all. It's good. The more the merrier here, because this task is not so merry. Okay. Yeah, okay, so we're setting the description. So we've got web delivery allowed. So we're just setting the flags in this bit field. No regional blackout. Archive allowed. And device restrictions 3. That's, I think that's none. actually, yeah. Okay, so that. Oops. Okay. Restrictions, the duration. Oh, it may not be set. Hold on. Oh, this one has a, ooh, interesting. Okay, so this one actually has more than one descriptor. So far our tests have only, the test cases that we've got have only been one descriptor. This one has two. Okay. Okay, device restrictions done, yeah. Okay, so there's no duration. So we'll set this UPID. I can't remember what that looks like. Type. Program. Oh no, sorry. Turner identifier. Oh, that's this thing UPID-TI. Again, another constant from the table. The value is a yucky thing like this, so we're just going to have to do this. So we're going to go 0, 0, 0, 0, OX to C, OX, oh yeah, that's it. Okay. And then the type program end. Now, did we already get that one? So this is the segment type, segmentation descriptor type. Yep. And then there's a huge table of these, which I feel like, yeah, here we go, defined in table 23, section 10.3.3.1, 10.3.3.1. Program end, they say. OX, I think it's OX11. I really need to have these as constants because, you know, I mean, this doesn't mean anything. That's useless. I really should generate a table, but I just, it's just so. Anyway, let's just keep going. So program end, go back to our sample. Type program end. Segment number is 0. The segment expected is 0. So then the sub is 0 because there can't be any sub elements when there's no elements. And then, yeah. Okay. All right. Now there's actually another one in here now. So this is new. So this will be good. This will test like the looping logic that we've done. Because there's a bunch of stuff where we need to calculate the size of the whole thing. And yeah, let's just see. Because we might have gotten lucky with some of those length calculations. All right. So starting again. Okay, the event ID. Restrictions, web delivery, no regional blackout, archive allowed to. Okay, so that's the same as this. We can just copy and paste. just a few more people here now. I'll just put this up just so we can see what exactly we're working on. Put that like this. Just be able to see maybe. Like that. Yep. Okay. Sorry, that's pretty tight, but okay, segmentation descriptor. Restrictions we've done. Duration is not set. Okay, so we go straight to the UPID. Type is the Turner identifier, which is this constant. Value A0. Oh man, another. Okay. Let's go. So that's 0. X to C. 4. Next field is type program start. Okay. So again, what was that table? 10.3.3.1. Program start. Oh, there we go. OX10. Okay. As I said just a couple minutes ago, really need to do that table of constants. But anyway, segment number is 0 and the segment inspected is 0. Okay, so that's that segmentation descriptor done. I think that's all the descriptors. Yep, and then finally at the end of our splice, we set the checksum thingy, error correction value, which is this bad boy right here. And then I think, okay. Let's see. Archive allowed. Oh, my mistake. Typo. Archive allowed. Archive allowed. Oh, all right. Oops. Yeah, nice. Okay. Oh, CW index. Okay. Oh, it's the same thing. It's this event ID compliance and stuff. I can already see it. It's that flag. Okay, let's just go through. So the CW index is always this. And then the I have a way to yeah, anyway, okay, well, I think I'll think of that later. But really what we should do here is that CW index is only ever used when the splice data is encrypted. So that is if we have the encrypted field set in the struct. But when we're encoding this splice, I feel like we shouldn't need to set this because we can just work it out that, oh, hey, the encryption isn't set. This CW index must be this value. 255. So yeah, we might write that down somewhere. Write that down here. CW index to OXFF when Splice is not encrypted. Okay. That's pretty good. And then in here we're going to do event ID compliance is actually true. Again there. Oh wow. Encoding and decoding, that works okay too. So we can handle multiple descriptors in our splice just fine as well. Whew. That's great. God, sometimes things work out. We started so rough today, and at the end, yeah. God, can't believe it. Look at that. Simple as that. Yeah, that's cool. Okay. What I might do is, oh, actually, you know what? Let's commit, because this is like a valid sort of iteration, let's say. And look at that, not a single code change, you just test those things. Okay, so make this shorter. Oh. Great. All right, let's I'm gonna tidy up maybe that CW index yeah. Yeah, let's do that. So how this is going to work is so we're going to do if it's not encrypted, then we append. No, let's do it if it's encrypted. Do the positive case, it's easier. Else what is this? It's a UN8, so we just that. now in our tests, we can just knock out that CW index thing because the users don't have to worry about it. We can just handle it in code. So we'll go, so let's do a bit of Acme stuff, x index plus minus d, all right? You know, in Sydney, where I'm in Sydney, the sunniest month is actually in August or September. Because in Sydney, we've got a bit of a, like, you know, it's a subtropical climate, so it's not fully like wet, dry season, but in summer it can really bucket down with rain. Oh. So the decoding. Oh yeah, okay. So we set, yeah, okay. So we're not decoding that value correctly. We're encoding it just fine. So let's find the rest of it. CW in. There we go. Oh no. Decode Splice info. No, I've got this the wrong way around, so I need to, when we're decoding, the value is always going to be that, no matter what. So I don't quite understand the change that I made. Oh. Yeah, this, like all I need to do is that. No? So when we decode, we're getting a different, we want 0, but we got 255. Okay. No, so, yeah, okay. Okay, so in the test cases, we still need to set the value as the max uint8 because that is actually the value that we're expecting if we're encoding as well as decoding. So yeah, we don't expect 0, we actually expect 255. But the code here handles the case of when we ourselves don't set it or whatever, which is what we want because that's the sort of correct thing. So if we go here, yeah, okay, so we'll just check that out again. All right, run the test. Yeah, okay, that's easy. So we can, okay. So this is just always set no, we're going to do this. The code, what it does is it sets the Splice data index for plain, so for clear, non-encrypted packet messages. Go. Hoping the gardening went okay yesterday. Hopefully it was nice and sunny like it is here now. Although it's not super bright, the sun is kind of a little bit low, but it's not as low as it gets in up there in northwestern Europe. I know what that's like. I lived in the Netherlands for 2 or 3 years, and 2 years, yeah, and that was tough. So respect to people who can, who get through that. Awesome! Wow, look at those tests passing. Well, okay, let's go here, so we can check off a few of these things. We've done that. No, we don't want to do that anymore, just because we're only appending splice time, I think, in one place, so it's okay to save a line. It's not, yeah, it's fine. Yep, we've tested more samples. So the only thing left here is what I've written here, use copy. So I noted down a few places where instead of like manually setting bytes, I can, it's 22 degrees yesterday, it feels like 30. Oh yeah, nice. Oh yeah, I remember that, mate. Yeah, like how, yeah, I remember the first day it was like over 15 degrees in Netherlands. I couldn't believe how hot it felt. And today it's, here, I don't know, maybe it's 20. Hold on, I'll tell you what the temperature is. I love the weather. It's 23 right now. And yeah, but if it was 23 in the Netherlands, I would be like, definitely would be having trying to get the most of it. But here, 23, I feel like I've got jumper on, I got pants, shoes and socks. Yeah, it's weird. And I'm in the sun, so yeah, it's funny. So as soon as I say that, big cloud comes over. Anyway, all right. So yeah, as I said, I want to use this built-in copy function because rather than like setting each byte in 2 slices, I can just use copy. Just going to see where I wrote that down. Oh yeah, for an economics exam. Oh wow. Nice. Yeah. That's look. It's very rough, right? I'm doing these big long streams, so I don't know whether, I'm hoping that, I'm hoping that you can skip through some of the stuff where I'm just sitting there going, huh, what? I'm just replying to somebody on YouTube there. I've got both streams going as saying that they're studying for an economics exam, but they just wanted to pass by and say that I found this channel, or that they found this channel, and they can't wait to devour the content of the series. And I'm like, yeah, No worries. Thanks for saying that. That's really kind. Humidity session makes me feel. Yeah, I know the humidity. Well, look, now it's 71% humidity, so it's very high. We'll give you a follow there. Oh, thanks. Yeah. I don't know how to, like, does your YouTube have a username? Is that how it works? Here we go. Yep. Okay. Yeah, that's that. That's got a bunch of non-tech stuff there too. So yeah, so that might be interesting for anybody who wants to cringe at hobby documentary stuff and yeah. People can people can discover that. That's cool. I'll just cool. Is that done? Yep, great. Alrighty. Okay, the copy function. So I found a few private command. Yep. Okay, so there's a function in here I found that could make use of the copy built in, which would make it a lot easier. Oh yeah, right. Hey, economics. Himalayan. Oh, I had a Himalayan. I actually sold it. Yeah, long story. I met somebody. I met a girl, and I sold the bike, and yeah, flew across the country, and yeah, yeah. That new Himalayan 450. That looks really cool. Yeah. Yeah, it was so great, that Himalayan, because and they're 400cc, 450, but having that like kind of low down chug was really great. I rode that bike almost around Australia, maybe like halfway. So private command. Yeah, okay, here we go. So we can simplify this. We can just dump in the, we can just use copy here. So we're going to copy. We have a buffer this big, so we're going to copy into buff from 4 onwards, anything from there, from that slice. So that's, look at that. Is that right? From 4 onwards. Yeah, that looks good. Now, do we really need it? Do we need this to be its own function? Yep, let's do that. Cool, test passing, all good. It might have been somewhere else. The DTMF, okay, so DTMF. All right, so this is a, oh, okay. No worries. See you next time. Good luck. Hope all works out well. All right, so we're gonna. So this is interesting for anybody who's into like old, weird No, it's not old, like it's a phone, but there's a way in SCTE 35 to actually represent a dial tone, like some, like literally like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 star hash as a slice of bytes. So yeah, here we are. I can't remember what it's actually, a Splice descriptor. Dual tone multi-frequency signaling. Yes, if there's anybody who's into like old school, like old school hardware, then like analog gear, then this is analog stuff here. Interesting. Actually, let's quickly have a look what this thing actually is, because the fact that we're even touching this protocol is like, God, Yeah, see, it's using voice frequency over telephone lines, but in this case, so this is good for history, right? So the way that we signal ad breaks in Twitch and other online streaming services has functionality to signal dial tones. Very handy. All right, anyway, let's not get too distracted. Okay, so what we're looking at here is 1 plus 1 plus that. Okay, yeah, so from here we can just copy, because we've already allocated enough memory, so we can copy the, all right, let me get this right. Yep, copy from index 2 all the way to the end, because we know we've got the right number of characters, and then we're going to append our dial tone. So d dot, and then we can just return like that. Less code, less problems, more happy. Splice descriptor. Okay. Is that done? Great. Wow, I can't believe we actually got through the to-do list, and it's not even the end of the day yet. So let's see. Okay, so there's some other things here. Well, I've just wrote down some notes. Oh yeah, okay, so there's a few errors that I think could be a bit, let's have a look at these error messages. Ooh. Oh, let's go font dot. Time single equals nil. Okay, so apparently there's some code here. Ah, yeah, okay, yeah, look, we can do that. So we can just go There, nice and short. Same thing, because we've already got the context. The caller will, will say what type of command it tried to encode, so we don't need to include it again. Wow, okay. All right, so that's that done, and then we're going to go on to, I think that's all this actual quick to-do list. Yep. Packed here. Close possible. Yeah. Okay. Jeez. Maybe. I don't know how. Let's just see how many people there are here. Maybe we want to do like a. Is it? I'm glad I found your channel from someone on Twitter who was wondering why some people use Acme and showed you a thing. Hey, Acme's great. So somebody just wrote on just here to say you're really great. Wow, thanks. That's so kind. Thank you. Melo on YouTube says, I'm glad I found your channel from somebody on Twitter who was wondering why some people use Acme and showed you it as an example. Who, I'm curious to know who, yeah. Curious to know who said that. That would be really weird to see somebody actually like recommending Acme, because, I mean, I don't necessarily, I mean, I recommend Acme, but it's really interesting. If you're there, Milo, you can send that tweet. That would be funny. Thanks. Yeah, maybe now let's just see. Oh yeah, as I said, let's see how many people are on YouTube. Maybe we want to do like a, because I'm getting pretty tired. Let's see how. Okay. Oh yeah, a few people. Yeah. Okay. Yeah. So I was curious to ask everybody out there. Let's put. Oh, actually, sorry. Let's just commit, and then we'll move on. Okay. So. All right. Oh, look at that, beautiful. More lines of code to delete. So. Cool. Let's push that. All right, so that code has been pushed now. So if anybody wants to have a look and see what we were doing there, streaming. Does that work? Oh, all right, no, it's HTTPS. Does that link work? Yeah. I think I'm going to do that. Okay, so now that we've finished, I was just curious to chat with some people if anybody wants to. Just curious to see whether you've got any other questions or whether there's anything that was, whether you think you want to keep going or maybe, so the plan for next time is actually to do something called MPEG TS. This is what I'm pretty sure we're going to do next time. After, because we've almost got this SCTE 35 thing. I think that's pretty much almost yeah, we've got to do the boring stuff that probably won't be so interesting to stream, like doing the documentation, like just double checking the error messages, seeing if it's all clear, that sort of thing. So once that's done, I'll publish that to the video dev forum, which is here if anybody's interested in like that lower level video stuff. This is a group that do a bunch of they're working at a bunch of companies that do, you know, streaming companies, stuff like that, that are working on this stuff for and actually getting paid for it. Wow. The next thing I want to do is probably work on this MPEG transport stream. So what this is a container, media container format. So you probably heard of MPEG-4. Is there a nice diagram? No, okay. So MPEG-4, you know, is like, you know, video.mp4. But in the streaming world, often what you'll see is this container format being used. This is a, it was actually originally designed for digital TV, if I remember rightly, so like sent over satellite and stuff like that. But they use it now still. This one is even older than a SCTE 35. I think it was made in the 90s. So if SCTE 35 was not old and weird enough for you, then this one should be, you know, this one's a bit older and maybe a little bit weirder. So how this one works is, then why it's different to MP4 is you can literally do stuff like, you know, you can cat, I think I've got a, hold on, let's see. Got a TS file? No. But basically it lets you like cat files around. So you can go out.ts and you can pipe that into FFmpeg, this sort of thing. Whereas you can't really do that with MPEG-4 files. That's part of the reason why it's used for streaming. So it'll be fun to do a transport stream package in Go, because then we could do things like I don't know, you know, like cut out things that we don't want, or retime things, or I don't know, really anything. FFmpeg, of course, most people use for that kind of work, but let's use GStreamer. But sometimes it's fun to just, you know, have something quite a lot smaller that's not written in C, especially if you're a really bad C programmer like me. Writing it in Go helps me make sense of it all. What I might do now is maybe just do a quick overview of SCTE 35, especially because I need one for, I need to record one, so I might just do that now if that's not too boring for people. I'll just open up the thing. Got our screen open there, yep. Just open up. Alright. Okay, so for anybody who's just joining us or missed the bits where I was talking about this, SCTE35 is a binary protocol, or binary message format more, that is originally from the cable television days. It's used to do things like signal ad breaks or any sort of break or stop or start of some video playback. I think it was originally meant to be, it's originally meant to be sent to like cable TV set-top boxes, but now it's still used in a lot of internet video streaming. In particular, the one that I always like to give an example of is HTTP live streaming, or HLS. HLS is like a video streaming protocol kind of on top of HTTP. So how HLS works is, for example, let's say you got your screen or whatever, some kind of device, right? Let's say a laptop. It will make a request to the World Wide Web, and it'll send back a HLS playlist. So let's say you want to watch, I don't know, like some World War II documentary. Now the HLS playlist looks a little bit like this. So I'll do this in blue. So it starts with some tags. It's like version. And then you've got a bunch of tags that tell you like information about the video and how long it's going to be, or what's coming up, what codecs are available, how big the files are, this sort of thing. But the main meat of it is that these things are called tags. This is another tag. And then you're going to have an actual video file. So this is going to be like segment1.ts. And then you're going to have another tag. And then you're going to have the next bit. So what's actually happening is that the player is fetching each of these. So it'll fetch that one for 2 seconds, and then it'll fetch the next one for the next 2 seconds, and so on. Where SCTE35 comes in is like how I've written here. Now, the tag isn't discontinuity, but it doesn't matter. In our case here, it's off the top of my head, I think it's date time or something. I can't remember. But there's going to be a base 64 encoded SCTE35 message. So this is SCTE35. So what we want is a package that is able to decode this and also encode them as well. So for example, what an application could do with our package is it could take in an HLS playlist and insert a bunch of breaks in there that say, whatever. Could say, hey, like we need to do an urgent news bulletin, or maybe we could write some software to read an HLS playlist and remove ad breaks. That would be cool. Maybe we could do it to change the ad breaks to be very, very short, like half a second instead of 30 seconds. There's a bunch of interesting things that could be done here. But this is just the library to help write those kinds of applications. We originally started the project by, how I originally found this was I was doing a job for work, and I found a package from Comcast, who do like cable TV in America, I believe. there's this package here, but what I found is that there was, I wouldn't call it like idiomatic Go, so it felt a little bit more like you're kind of reading Java, but it's written in Go. The other thing I found was that there's a lot of code. So I think this thing clocked in at over like 4,500 lines, something like that. Anyway, something like 4,000 lines. So there was that. Didn't really like that bit of it. The other thing is that it uses external dependencies, which I thought felt not super appropriate, especially because this is a binary protocol and Go gives you all sorts of stuff to deal with binary things. It's a standard feature of pretty much most languages, especially one that can operate at like a lower level. You don't need any packages to shift bits or append bytes. They're just bytes. So I wanted to get rid of all those dependencies. The other thing I wanted to do was add some more testing, or at least have some clearer test outputs. So when working with the package, I found that the testing was a bit like, yeah, they had end-to-end tests and stuff, but like if you did something wrong, then yeah, I don't know, it was using this assertion library, and again, it doesn't feel very Go-like. There's a really good talk by Russ Cox on who's the lead of the Go project, about just a whole bunch of really useful and interesting testing like tips in Go. Super handy. I might link that in the description in YouTube and in the chat. But just to remind myself, I'm going to put that in here. I think it was testing by example. That was the name of the talk. It's a great one. Highly recommend it. Definitely want to try and put some of the, to try and use some of these tips in this project, and other packages in this project. And the boring bit is that, of course, we've stripped like a whole bunch of documentation, because it was just copy and pasted from the specification. The thing is that with documentation, documentation also needs maintenance, just like code does. And if we're able to just link to the spec or refer to it in some way, like section 10.3.3, that's a lot shorter and a lot less documentation to maintain than actually like just copy and pasting stuff. So that's what we've been working on for the past sort of week. I hope it's interesting. I hope it's not too long. I hope it's not too boring, that just kind of like sitting there going and getting all these things, like mixing up 33-bit integers and packing things in the wrong endianness and all this sort of thing. It's been a big learning experience for me, and I hope it's sort of useful or fun, or if you're working on something similar, or if you want to just say, hey, like just anything, like just write in the chat or send me an email as well. I know that's a bit old school, but I think email is really cool. So thanks for listening to all that. That's good. That's going to be like the intro, I think. I'll need to split that out in the edit later and add it to YouTube or something. I don't know. So let me just think what else could be next. We've done the MPEG transport stream stuff. We've added a bunch of tests to the package. I wonder, let's just see. I don't know whether one of the other to-do items is actually working out how this file is or was generated. So right now this is an array fixed size array of a bunch of, what are these? This is unsigned integers. Yeah, okay. The thing to do would be, the idiomatic thing to do, I would say, would be to have a go generate line and then have something that spits out this. Maybe even just a link to the table or something like that. Maybe even a link explaining where to get the table from. That would even be fine too. But as it stands, it's a bit, yep, no good. Yep, so there's that. That's to do next. Also, I know. Let's have a look how many lines of code we've got now. 1,355. Okay, so we've deleted, as I've written in the little, what do you call that? The text across my face is, 1,300 lines, and I think originally it contained, a lot more. So, and it had dependencies. So this has 0 dependencies and 1,300 lines of code. So I think that's good. I think this will be a lot easier to use and maintain later. I'll just see. Yeah, look, to be honest, I think I might just put it onto the chat. Where do I go? Here. There we go. Yeah. Pretty good for today. Can't believe we got through all that to do. Yeah. Okay, somebody here asks, let's change this. Let me just write this. Assad asks, hello, how long have I been programming? So I've been doing software development now for like 5 or 6 years, something like that. I started off doing SRE, or sort of DevOps, that sort of thing. But I've since, about 5 years in, I realized, doing system admin would be easier if I knew how to program, because I could write more than just shell scripts to get stuff done. I was also using software that I didn't like using, and so, that's what you do, right? When you're using stuff that you don't like using, you kind of need to do something about it. So that's how I started programming. That's how I picked this kind of software to work with, was because I never really did any web development. I still have barely done any web development or back-end work, as people say, or front-end. I haven't done much at all. I barely know how to use a relational database. People keep asking about this text editor, so maybe I should do a little bit on it now, because everybody asks about this Acme editor. And who is that person's name? Malo. I really want to, if you have that tweet somewhere, I'd really like to find, it would be really funny to see what the, where that tweet came from. Okay. Assad asks, did I write code every day to get ideas of what to code next? I probably wrote maybe not every day, but certainly most days, even if it's just a little bit of like even a little shell script, I get into the habit of you know, for example, right now I wrote a tiny little shell script that streams, you know, with FFmpeg. So if I show here, this here is the output of a little shell script that I actually write this, just to answer your question. This is actually that's a good question actually, because it's something that I think about quite a bit. So how this streaming setup is working right now is that I've got this my computer that I'm on now, and then that goes to the loopback interface, so LOO, or people call localhost. This streams RTMP, real-time media protocol, multimedia protocol, can't remember. And then FFmpeg is actually listening there, and then it goes out RTMP to Twitch, and one goes out to YouTube. Now, there's a bunch of online services that do this for you, but you know, we can write a very, very tiny program that actually does this for us. FFmpeg does, of course, 99.9% of the work, but getting into the mindset of using a shell script to do that instead of like signing up to some web service to do that for you, I found that that's helped me keep sharp with software engineering stuff, because you know, even a shell script can be well written or badly written. A shell script can, you know, be confusing when you come back to it years later. So writing tiny little bits of code like that, yeah, I try and do that most days. Thanks for the question. I guess next, maybe we should do the old, let's do the Acme thing maybe. Are we going to stream about Acme? Seems to be very, very popular. Maybe I should save it for another time, I don't know. Hey, Harix. Oh, yeah. Hey, Harix, can you send me that tweet? I really want to see what that tweet is. I just think it's so funny that somebody tweeted about Acme and now like it's here. It's just ridiculous. If I didn't know people still use Twitter. I thought it was kind of, anyway. Yeah, Harix, yeah, if you could send a link to the tweet or post it in chat or something, that would be super funny. Thanks. Assad says, that's a really great mentality. Actually wanted to use FFmpeg for my own side project before, but didn't really know where to get started. How do you get to know stuff on a deep knowledge? I think, yeah, just, this is sort of boring, but reading, doing little projects like this, I don't really care that it's about add signaling, but what I do care about, or what I find sort of interesting, is how, you know, how stuff at this level could work. And that means just learning about it. So the difference is that I had something like this working before, but I kind of wrote the code and it kind of worked, and I thought, oh, okay, well, that's great. But if I wanted to make the code smaller, or if I wanted to make it easier to understand, oh, they don't allow links. Sorry, 2 seconds. Moderation. Okay. Yeah, Harix. Yeah, it looks like it doesn't allow links or something. I don't know how I don't know how exactly this chat thing works. Sorry. You can get esoteric coffee. Okay, that's awesome. Cheers for the handle. I'll definitely have a look at that. Okay, sorry, Assad. So I was saying that, yeah, so there's a difference between like writing the code and getting something working. I think that if you've got an interest in making code that kind of makes sense when you look back at it in a year's time or 6 months' time, then I think getting deep knowledge helps, because, you know, if I was doing, for example, the bit shifting, when I was doing the bit shifting stuff in this file, where was it? How do I do this? Here we go, like this. So this is just 2 lines of code, but I learned about, well, to make that 2 lines of code, I had to get a deeper knowledge of like what a bit mask is, about this, how that works, and then what that means, and big endian, and then appending the thing and all that. So I feel like so wanting to make things like that instead of very big or, you know, drawn out, that helped me get a deep knowledge. Yeah. If you want to get started on FFmpeg for your own side project, maybe one of the fun things that FFmpeg could do is it can write to any sort of output. So one thing that I always thought would be a fun idea was FFmpeg can, or rather FFmpeg can read and write stuff quite well. So for example, one thing you could do is you can write FFmpeg, and then let's say you write out some stream in some format. Doesn't matter what format. Let's say it's audio, let's say it's like a WAV file, and then you read that into your program. So this is Assad, and then you just read it back into FFmpeg again, and then you hear the audio. So for your program to be able to do that, you need to know like quite a bit of stuff. You need to know like how to decode this, how to encode it again. Maybe you want to like change the pitch of it. I don't know, I'm just making this up on the spot, but often I find this way of coming up with programs that feels natural to me because of all the, you know, the sysadmin and the Unix stuff that I've done. So you can write this software that like puts itself in between other programs. So that's how I often come up with different ideas. I kind of think about Unix pipes and piping in general, and yeah. Let's see this. Oh, nice. Thanks, Melo. Yeah, sorry, I don't know how this chat system works. Sorry, that's super funny. Thanks for yeah. Let's have a look. So I need to do post 178. So I guess, like, do I go on to Twitter? Is that the thing that works now? Does it still work? No. Let's see who's saying what. So apparently somebody has how do I That's good. That's funny. I don't think I've ever tweeted. You know, yeah. I've never had a tweet like that before. Yeah, well, you know, Acme's great. It's a good, fantastic editor. It's it's an IDE that's not an IDE. Weird seeing my face there, yeah. Then you can see what people say, right? Instance has been rate limited. Ooh. Oh, there's one in Australia. They're saying here, I used it when I was obsessed with Rob Pike and Russ Cox. But Vim plus Fuzzy Finder eventually won. Oh man, okay, don't tell me I'm a different species with that. Like, what? Is that, no, this is Acme, right? Oh man, this is, yeah. That's different, man, come on. Like the bitmap font, no, you gotta, it's so fun to use. I'm usually on Emacs and make my mouse work as much like it as I can with defaults, but I still go to Acme sometimes when I really want to focus on without worrying about syntax, coloring, or themes, or keyboard shortcuts, even files and directories as much. The keyboard I'm using is, I can show you, it's this really old one. I think it's like 10 years old or more. It has these really annoying lights on it, but let me just see if you can see that. Yeah, it's a Ducky Shine. It's got cherry browns in it. Yeah, that's great. I thought he's an OpenBSD user. Yes, I am. I always use OpenBSD, but for streaming I use this Mac just because, you know, I have this iPad and all that sort of thing set up with it. But I am going to get the I'm going to get this my OpenBSD machine streaming, because yeah, I prefer that to Mac OS. Although the display on this iMac is fantastic. The OpenBSD operating system, beautiful. Lots of fun to use too. What else are people saying? I picked it up at like age 18 and a woman. Long story short, I maintain my own little patch set now. Yeah. It is like that, yeah. Because there's no configuration to Acme. You can't, like, apart from changing the font. So normally the font that I actually use is what is it? Yeah, that's usually what I use. So usually I use this font. So I don't even use, I don't even use a monospace font. But yeah, I know that's weird, but I don't know. I don't mind it. It feels more like I'm reading text rather than reading code, which I kind of like. But yeah, it's annoying because look, see how it doesn't align properly. But that's me. Can't authorize more than 2 spaces per indent. Oh yeah, this isn't too bad. This is 5. This is 5 spaces per indent, which is, I don't think it's too bad, especially with a variable width font. The tabs don't take up that much room, so, and who's using spaces for indentation anyway? This is a Twitch stream for civilized people, not animals. We use tabs here. Plan 9 for the win, yeah. This guy's been blowing up on YouTube lately. What? I cannot believe this. Oh, using SAM. Okay, so what is SAM? So SAM is like it's hard to explain, but basically it's like a floating window manager version of Acme. So SAM came before Acme. So if we want to open a file, wait, where are we? Let's see. Okay, yeah, so if we want to open a file like this is really let's say Splice. Oh, or not. Splice info internal SCTE35. Oh, like that, yeah, not bad. Ah, of course, yeah. So let's do. There we go. So so this is SAM, and how it works is a little bit different to Acme, where you can manually set your windows. So if you want to open up another file, let's say like let's say the test. So you just go test. That, and you set that up, and then from here you can just do all your code, whatever, blah blah blah. And then this is kind of like in Vim, how you have you have command mode where you have your little line at the bottom where you write commands. It's the same in SAM. So if you want to say you want to write this file, you just W and it saves the file. You want to save this file, select it and then hit W and you've saved that file. If you want to replace text, let's say you want to grab, oh geez, I don't know, let's say out of this file you want to get everything from SAP, and then you want to insert the word, you know, tree, then you'll have all of that, and then you undo it. Yeah, so just the same as Vim or ED or ED or VI or whatever. Yeah, so yeah, it's a fun. There's a really deep rabbit hole here with the command language. It's kind of like regular expressions, but they're called structural regular expressions. It's a whole bunch of crazy stuff you can do that I maybe won't go into now because it's yeah, I need to think about how to demo that thing. It's a weird one. The weird thing about Acme is that it actually exposes itself as a file system. So if I go into, I can actually read the contents or access the contents and modify my environment reading using a file system. So for example, if I want to like create a new file that has the word like hello world in it, then I actually can just echo that to a file. Yeah, Sam is a text editor, yeah. I think, is that the command? Yeah, there we go. So you can create and, you know, stuff just using regular, you know, file access primitives. Super weird. You can read stuff. So if you want to read what is, for example, in here 132/tag, I think it is. Yep. So see, from there you get the contents of window 132, and the tag is this bit. So right now we've read the contents of this file, which is just the tag. So that's super weird. Yeah. Anyway, yeah. So 2 minutes ago we've just been streaming for 8 hours, which is a official. That's an official work day. So I might need to call it, but yeah, as I say, anybody? Oh, Fadri. Oh, hey. Oh, wow. Yeah, yeah, I remember you. Of course. Yeah, yeah. That's anyway. I'll speak to that person afterwards. But yeah, if anybody wants to see anything or hear anything in particular, or you've got questions, or yeah, as I say, email me or write it in the chat, or you know, I know email is kind of old, but I like email. I think it's cool. Yeah, sure, absolutely. If you is that the link? I'm hoping you can see that. Yep. So yeah, right now it's just me and my friend, and my friend is very busy at work, so he can't write anything. But it's nothing official. We're just, you know, we're just hacking on stuff. Yeah, look. So I actually have that book here. If you wait 2 seconds, I'm just going to get the book because I actually have it right here. Hold on. Okay. Sorry, I was just getting the books. So, Go programming language. I recommend reading this book because it's not really big. So, and I found it really, like a good read, really clearly written, full of examples. It's old. I mean, I think it was published in 2016, but to be honest, the Go, the programming language hasn't, it's very, very stable. And so, yeah, the things that have changed have, of course, things like generics, the type parameters. I've actually never used the type parameters in Go. The other big thing that's been new is the modules, Go modules. So yeah, a couple of these instructions in this book, they say like, oh, just go get this thing or go get that. Whereas you wouldn't really do that nowadays because, that's not how you really get packages. But apart from those two things, yeah, like the language is very stable, and what sort of like, for the most part, I think what is like normal or idiomatic or regular Go, I'd say the book is good. Oh yeah, hey there, always. Sorry, I don't know how to pronounce your name. So this is somebody on YouTube. I should really, what I should do is I should put the chat up here just so everybody can see what I'm talking about. Let's put something like that. And I'll put that there. All right. So this package, all the best. Let us know how you go reading it. It'll be interesting to see like if you find it useful or something, because I read it a long time ago, and every now and then I'll look at it, not so much for the Go stuff, but actually just to see like how to write things clearly. Let us know how you go. Somebody asks, can I fork the repo? Yeah, sure. Like, it's open source. It's under a very permissive license, so however you like. And if you want to fork it or like send patches, however people do that, like 100%. Whoops. What is this package for? Don't understand the whole of it. Like for fun or work, I saw it up on YouTube, so decided to watch it. Okay, so this is I actually explained this just a little while ago, so sorry if anybody's going to be bored by this. I'll just say really quickly. But basically, if I put that here for now, it's a binary message format, and so we're writing a package to encode and decode these messages that are used for ad breaks. Most common place you'll see it now, at least in the computer world, is in HTTP live streaming, or HLS, which is what is used, at least on Twitch anyway. On YouTube I think they use MPEG-, but anyway, so that's used to stream video, let's say like it's used to play streamed video. It's used to signal ad breaks on broadcast TV and also in internet streaming. So kind of an exercise, kind of something to do with learning lower level stuff. It's like it feels quite hard for me, because I'm certainly not the best programmer in the world. But it's also a good like software engineering exercise because, you know, yeah, no worries. Yeah, I guess YouTube is like recommending this or something. I don't know how all that works, but yeah, however it works is of course all the secret magic, right? Thanks to closed source software. But hey, what do you do? Somebody here says. Somebody here writes, it's a good editor, but the best takeaway besides pipe shit through filters is that code looks better with proportional fonts. A take too powerful for most to accept. Yeah, no, I normally use, you know, a regular, you know, variable width font, or, you know, like a proportional font. Yeah, it's good. I changed it to monospace just for, you know, for streaming, so people didn't find it too weird. But yeah. There's something else than Vim or Emacs. Yeah, absolutely. Yeah, I mean, I think everybody now just uses Vim or VS Code, right? It's pretty boring. There's a whole bunch of other ways to, you know, to use text editors. So I think, yeah, it's good to try something different. I'll use SAM, or I mean, I know this is going to sound really dumb, but like I'll literally just use Notepad, because, you know, the shell, you know, the shell, like the terminal, you know, that gives you most of the stuff you need, right? Like I can run go test in a shell. I can, you know, I can read files, I can write files, I can, you know, find stuff with grep. You know, it's a bit ghetto, but you know. Mouse chords. Yeah, so mouse chords there. So this is, yeah, mouse chording is this weird idea where when I, normally when you want to, let's say, copy and paste something, you select the text, you hit, you know, X, Command or Control V. But what you can do in Acme is use this idea called mouse chording, which is you pressing different buttons of the mouse down at the same time. So like that, using two buttons. So in Acme, you can select a bit of text with the left mouse button. I'll try and demonstrate it. And then, it's going to be too hard to wait. Oh no, maybe I got to do it. Okay. Okay. So I'll select this line, or these lines. And then if I want to cut it, then I'm holding down this button, and then I'll middle click at the same time. Oh no, fuck, I missed it, sorry. I gotta do it right, yeah, there we go. And I'll middle click. Yeah, and then to paste it, I hold down this button, the normal left mouse button, and then I right click, and that pastes it again. So it's, yeah, it's just a thing. It's like a Plan 9 thing, which is, yeah, anyway. The other thing with the mouse is that you right click to load things, say, or to get stuff. So if I right click this, that text, then I'm kind of loading that. But the same works for even things like URL. So if I want to go to, you know, like open, or let's say p9f.org, right? So if I just type that text and I right click it, then I'm taken to here. There's a whole bunch of weird stuff you can do. It's another program is actually handling that, but it's built into Acme. Or yeah, that Acme is built in to communicate with that other program. So you can do other stuff, like say if you open, you know, let's say you open a PDF, then you right click it and it'll open it for you. You can, you know, plumb mail addresses, you know, know, so if I click that, it'll send an email to me or compose an email, that sort of thing. JetBrains, yeah, yeah, I never used that one. I know that when I worked at a Java shop, a lot of people were using, what's it called? I can't remember what the editor's actually called. JetBrains. Yeah. Anyway, that sort of editor for writing Java seemed to help a lot. The autocompletion was amazing. Yeah, IntelliJ. Yeah, that's it. Of course. Yeah. Thanks. Yeah, IntelliJ. Yeah. That's that's a whole different level of stuff. Yeah. Yeah. The thing that's fun about Acme is that it's really easy to sort of write programs that can be used from Acme or by Acme. So, for example, one of the things that is used is, so this is actually all the GitHub issues for this particular project. So this is actually a program running in Acme, but it's really just a file. So the way you can use it is exactly the same as anything else. So let's say I click new to, now I'm writing a new issue. So I could do something like, I probably have an issue. Let's have a look. Oh yeah, I know one. Okay, so I'll do the package name, internals, go to 35. This is going to be, so generate CRC32 table programmatically. So the issue is, I'll just write a quick one. So the issue is generated or where they come from. If they can't be generated truly, then maybe a link to somewhere where go. Now the thing is that because this is a normal Acme window, you can just use your normal commands. So like, for example, if I wanted to, if I wanted to indent all of this, I've written a tiny little command called A+, which indents stuff, and A- to de-indent, and A+ and A- are, it's just a sed script. So the plugin is literally just a sed script to indent or de-indent something. But you can do stuff like you can pipe it through formatters. You can say like, I'll pipe it through format to wrap the lines. Again, you're using a different thing, so you can just like, undo. Anyway, yeah, so let's, okay, so we've written an issue. Let's save it. Okay, and then if we reload that, we can see we've got one issue. There we go. And then if we actually open the link, right, again, by just right-clicking it, because it's just a thing, then you can actually see the issue here. Pretty cool, pretty cool. I've written a bunch of other programs that I use in Acme. Yeah, stuff that's kind of Plan 9 feel. But yeah, anyway, yeah, that's maybe for another stream. It's possible to interact with the JDK to run Java in Notepad. Yeah, so somebody writes, let me just grab the, so somebody writes in the chat, you can edit code in editors like Notepad, but with Java, it's so much more difficult to use the language productively in those kinds of editors without any help, which is crazy. Yeah, so I heard somebody once refer to this as the, like Java is an IDE language. I don't know, I've worked with Java and I think I was definitely a lot slower just using like Notepad than the other devs who were, using, pretty sure they were just using IntelliJ. But I only ever needed to, write a few lines of code here and there to fix up logging and stuff like that. So I think if I was really doing development every day, I probably wouldn't use Notepad. But yeah, I literally use Notepad to, do a bit of development on a big, how many lines of code do they have? Like 400,000 lines of Java. It's a big insurance company app. Ugh. Yeah, it's interesting. Hey, I think it's possible to interact with the JDK to run Java in Notepad. Yeah, that would actually be super cool. Yeah, so it's kind of like that, what do you call that? The, like the programming language server, but then to have the whole, instead of needing to write the, instead of needing to interact with the server, you can just interact with the JDK. That's really cool. With the JDK, with the JVM. Yeah, it's things like having the, what do you call it? The, like a REPL running all the time. That's really cool. In Acme, you can have like terminals and stuff like that too, right? So you can run a program called win, and then I've just got a normal terminal here, so I like to use this shell. So if I go here and then, I can like read a file or, like stuff like that. That's helpful too. So if I wanted to, I could run, a test from here and then that sort of thing. Useful because then, remember, all the same rules apply. So I can just edit this text however I want. I can load this file if I want to, because it's just text. So it's very text IDE. It's not like a terminal. Yeah, it's very text, if that makes sense. It's a weird way of thinking about it. Yeah. All right. I think good. That's good. That's good. Yeah, good stuff. All right. Let's close that up. See how we're running here. Yeah, might finally actually call it call it finally, because I'm getting kind of tired. We're going for about 8.5 hours now, so current issue posted, where is the array and what are the values which are being stored in it? Okay, I'll get to this. So why don't we use Sam for this, eh? Just because people are asking about Sam. Thanks, Assad. That's yeah. I'm gonna be I'll be here tomorrow. Yeah. So if anybody wants to join tomorrow, we're gonna be here too. And anybody else, everybody's welcome to the SCTE 35 club. It's the worst club to be in, but hey, somebody's got to be in some sort of club, right? Quickly go to this. So Jay from the Goonies is asking, here, so from the current issue you posted, where is the array and what are the values being stored in it? So I've got this thing here. It's this thing here. So it's this CRC32 table. So this is an array of, oh yeah, here we go. This is a Sam Acme thing, all right? So see, I just pipe the value to word count, and I see I get 257 lines. So there you go. It's the real thing. Yeah, so there's these 256 values maybe. I don't actually know what those values are. I assume, yeah, I don't know. It's just something I haven't looked into yet. Yeah. But yeah, this thing, yeah. We could have a look and see what the where is that? No, so this is an assembly. This is these are 1, 2, 3, 4, 5, 6, 7, 8. These are hex literals. So so these are just numbers. One way to think about it. So they're just it's an array of unsigned integers. And so in the array we've got 1, 2, 3, 4, all these values here. So I'm trying to find that. Oh no, that isn't the thing I wanted. Yeah, so the yeah, sure, 100%. Yeah, go for it. I'm getting pretty tired now, so I think I should stop. But if you know what I'll do is give me a sec. Let's quit out of this. Where are we? Okay, so let's see. So this is. I'll just quickly add a comment in here for you, just so maybe I don't know. Let's just see. That's CRC32. And then in the spec is going to be here. Good find in MPEG systems. Yeah, right. Okay, so no, okay, that doesn't. Yeah, let's see. Whoa, okay, this thing is over my pay grade. Yeah, okay, let's just do that. All right, let's close that up, and yeah, let's okay. That's officially okay. So yeah, thanks everybody. It's been a lot of fun. So yeah, thanks, and yeah, I hope we can all have fun doing more of this stuff together in some way. Cheers. See you. I'll probably be back online in something like 18 hours. So I'll be back in 18 hours. So if anybody wants to join, yeah, I'll be online for quite a few hours from that time onwards. Okay. Cheers. See ya. Thanks everybody.